meeting is being recorded.
Right, good morning, everybody. This is Ben, President of the Robotic Society of Southern California. Welcome to the monthly meeting. As usual, we have two talks. The first one gonna be kicked off by Alan. After that, Jim Ubersetse will continue with his talk. After that, we'll break for a short lunch and then come back with our show and tells and a discussion on the upcoming contest. So, Alan, want to take it away?
Yeah. Let me, apparently today on Zoom, I can't share my entire screen. Okay. Yeah, no, well, we're good. We are going to.
I forget what operating system can you use?
I use Arch, by the way.
Yeah.
All right, let's see if we can make this work. Okay. We'll just transfer my tabs over here. All right, let me get my password. That out. All right, so after focusing on OpenClaw and agents and personalized assistants for months, I finally was able to pull myself away and turn my attention back to Elm. Where we left off and my utter failure to participate in the previous contest had everything to do with some assumptions that I made about my ability to run that group model on device. And Alfie is actually now in his third generation of CPU hardware. The first one was a RockPi 3588, and then I upgraded to an Orin NX 16 gigabyte, which in theory should have been able to hold the model. The model is only 3 billion parameters, so even at 16-bit resolution, that's 6 billion parameters. But with all the other rigging and everything else that's involved, I could almost barely get it to fit with literal nothing else on the board. So I ended up running the model on my Orin AGX and connected over Wi-Fi. And when I got here, trying to get those two to talk over Wi-Fi on campus, failed. So that was a stopgap measure. So the next step for me was, I already bought the AGX. Let's just put it on board, right? So now we're one generation behind compared to the Thor. And where in the previous generation Alfie, the buck down converter was here, which was smaller. There was plenty of room to put the AGX on board, which you can see back here as well. And updating the base to be able to fit it. Sliding the bracket up a little bit for the battery. And as my favorite electronics guy out of Australia says, Bob's your uncle. We are good to go and everything fits. That was the easy part. Now the challenge is everything that happens after that. So when in the previous generation hardware, and I probably need to rename everything because technically there's 3 generations of hardware. In the electronics bay at the base, it was a really tight fit. The Orin AGX fit on bottom just like so, and there was barely enough room for me to chop down 2 of those WaveShare general driver boards. Which are amazing little things, and then they bang for the buck. They're great. They've got they can talk to serial bus servos. They can read motors with encoders. They can drive 2 different peripherals through PWM. They have an onboard IMU, with Wi-Fi. They're an ESP32 board. They are kind of amazing. I'll try to get these things into chat as well. And up through Gen 2, they were perfect. But now that I need to make room for my 30 amp buck down converter, which takes up a little bit more room, these driver boards don't fit anymore. And so now starts the dominoes of required and optional hardware upgrades. While we're in there, sunk cost fallacy, in for a penny, in for a pound. And let me walk you through all of the hardware changes that I have either done or I'm working on today. So I can't use the general driver boards anymore. So those are out. Now I have neck servos and arm servos and hand serial bus servos to control. And even with these guys, let me find another one. So here's another shot of the Orin NX board. This was the smallest carrier board I could find for it. Oddly enough, it fit in the same space as the previous gen. Oh, sorry, I keep forgetting to switch tabs. Sorry about that. And let me see if I've got a shot of. I didn't get a shot of the 30 amp bus board. But now I've got to figure out how to control everything. Now, starting from the bottom, I need to be able to control these 4 servos with encoders. And there just so happens to be a really inexpensive high wonder board that can control up to 4 12-volt motors with encoders. And it's small and it fits in the space that's left in the bay. Awesome. Let's order 2 because you always want a spare in case you do something dumb and let out the magic smoke. Got them in. Great. And the board by default communicates over serial and I2C. Oddly enough, the serial protocol is not really well documented. The I2C protocol is better documented with specific addresses and specific address. Well, I2C and specific addresses for registers to pull in, pull out data, because you need things like what is your encoder reading, right? Set the PWM frequency, all of that, and that's all better documented. But there's a problem. There's no MCU on here. It wants to communicate over serial or I2C. And there may be some pins on the AGX Orin that I could have connected to. But I have already, sorry, I'm transferring over tabs, 2040. I've already used one of these amazing little boards. They're a Raspberry Pi 2040 in the 0 format with a whole bunch of I/O pins. And one of these is actually what drives the motor driver for the back servo already. So I already have code in there. I have a repo that programs this to speak over serial over USB for ROS. Okay, so let's use one of these to connect back over to one of these little guys, and then we're good, right? Over I2C.
Otherwise, you don't have any other MCU to talk to it. Or,
right,
oh,
yeah.
I see. You could have used. You're saying you could have used something on the Orin, but
yeah, maybe. But yeah, let's just.
But why go all the way to that?
Yeah, yeah.
You
So
just need a small MCU.
Yep, and that's going to be a recurring theme you're going to see with this refit is pairing up. And I bought a lot of them. I brought extra. So if you want one, let me know. You can have them. I bought a lot extra because I forgot that I already bought them once. And they're cheap.
They're $4.99.
Yeah, or less when you buy in bulk. So we'll pair these up, and that will be a recurring theme in this refit is finding a board to communicate with something, but with no MCU. We'll buddy it up with a Raspberry Pi 0 And then all of these guys will communicate over serial over USB. And I have 2 USB ports accessible without it looking weird. So each one of those goes to a 1 to 4 USB splitter. So I have a total of 8 USB ports. I won't bore you with what connects to what, but it'll work.
And those go to the Orin.
Yeah.
Okay.
Yeah. So we're going to do I squared C. Now, for anyone familiar with I squared C, you've got a clock and a data line, right? And it's a master and multiple slaves. There's a high speed mode and a standard mode. And it turns out that if I want 50 hertz updates of encoder positions and command positions, 100 kilohertz clock rate is perfectly fine. It's more than enough. It's roomy and spacious. But you need something called a pull-up. So each of these lines are floating. So you need something to pull that line up to your signal voltage. And I've already confirmed that this board takes 3.3 volt I squared C signal, that it's fine. And your Raspberry Pi 2040 also is a 3.3 volt device. So for those of you coming from from Arduino, that's probably the biggest change. Arduino wants to work at 5 volt TTL logic signal. A lot of your more modern ones are 3.3 or 1.8. Awesome. Now, the next question is, how do we pull that line high? When you look at the Raspberry Pi 2040, you do have an option when you define your I/O lines to, I'm sorry, we're talking about the Raspberry Pi, we'll just flip it back. You do have an option. Let's find a better picture here. For a pull-up, when you define the I/O lines. Awesome. Sweet. But I have to share this tab instead. Thank you. Please remind me every time I'm forgetting to hit share tab.
Is that better than just doing share screen or the thing?
Well, I'm sharing individual tabs. For some reason, I can't share a whole screen right now.
Oh,
I use Arch,
it's
by the
not
way.
working.
Yeah, it's just, yeah, it's,
All right.
yeah. Something else is broken that's resulting in my Arch not being able to do it. It's never my fault. It's never Arch's fault.
No. It's yeah.
But when you look into the pull-ups that are available for the Zero, the pull-ups are in the 50 to 80 kilo ohm range. And when you do the math on best practices for the resistor you want to put in line to pull up these communication lines with 3.3 volts, it's actually 2.2 or 3.3 volt, 3.3 kilo ohms. 50 to 80 is way too high, and it will attenuate's the wrong word, but it won't be able to communicate fast enough. The rise call times will fast it. And well, why would they even put it on there? The Raspberry Pi, the Arduino has dedicated pull-up resistors on the board that are correct for 5 volts and 3.3 volts. Why the Raspberry 2040 would even have this if it's not right? Well, the pull-up resistors aren't designed for I2C communications specifically. They're designed to give you just enough current to pull it up from floating. So they're the wrong fit. So then the second question is, does my Highlander board have pull-up resistors? When you get into these budget boards, I'm not surprised anymore. Like they had a step file. Like I'll show you this. They had a step file of the whole board. That's awesome. Did they provide a schematic? No. Is there good documentation on it? So how do you figure it out? Well, the first thing you do is you look at how the board's set up, and you look right here and like, oh, that looks like a power regulator. And then if you get a magnifying glass and look it up, it's a 5 volt power regulator. Definitely it's used for the control logic on the encoder boards. Maybe they've tied this by a resistor over to the SDA-SCL to bias them high. So you take your voltmeter, your ohm meter, you check all the lines, or say, and you're not getting any reading at all, or it fluctuates wildly. Inconclusive. So the next thing I do is I power up the board, and then I take my voltmeter and check clock and signal to ground to see if I get any voltage. So if it's being biased high at 5 volts, it'll show up, or 3.3 volts, and I'm not getting anything. So I guess decisions by induction or deduction, There's no biasing resistor set up on the board. The one on the Raspberry Pi
The wrong.
is the wrong one for that. So we're gonna bodge it. And while I am both proud and not proud of this, I dug in my drawer. I grabbed two 2.5 or 3.5 kilo resistors. Either one would work. I pulled the 3.3 line. Let me see if I've got the. I pulled the 3.3 volt line out, and then I just soldered them in. So problem solved. We're looking
Pull
good.
up resistance. So.
Yep. And I'll show you the model in a second. There is a Raspberry Pi 2040 step file and a step file for that, so I can pull both of these into Onshape, and then I can design a couple of pieces of plastic to hold everything together. So the bottom panel keeps the stuff from shorting on the bottom. The top stuff holds the Raspberry Pi Zero in one spot. And the way it sits in the electronics bay, nothing will get shorted. And that pigtail you see off to the side, I need 5 volts to drive my speaker amplifier. So I'm just pulling that right off the 5 volt ground line that's being fed directly from it's a USB-C connector, but they're USB 2.0 pins. Basically just like the original amplified speaker did. So let me see if I can find it. So back over here. So first set of engineering challenges have been solved. I have a self-contained 4 motor mechanism drive unit with Raspberry Pi 2040 with a case that keeps everything out of the way that might short when I throw it into when I throw it into electronics bay. And I've got a power lead that's fed out. So now we can control all 4 motors off of one of the 4 USB ports that'll be fed from my 1 to 4 adapter that sits in the base.
Just a random question. How much heat is that gonna go out? Because that seems very frustrating.
Probably not a whole lot, but even if there is, the electronics bay has two 40 or 50 milliliter fans that draw air through it. So there is a little bit of airflow through it. I'm not anticipating a lot of, because those motors don't pull a lot of power, definitely less than the servos, but it's a good thing to keep an eye on. So when I do systems integration and integrate that 0 and write in the code to pull information from the board, I'm hoping there's some kind of a temperature reading that I can pull back as well. So we'll see. So the next thing. Okay, so we've got the drive wheels figured out. We're set there. The next challenge is power distribution. So when I initially built this guy, I used probably too small of a wire gauge. And as a result, I had a lot of home runs between the electronics and the base, and everything needed to feed power and signals to the arms and the head and all that stuff. That was a lot of wires. So Denny and I were part of this. We pulled all of those out, and the option is now to simplify the wiring harness. So we're going to do it right this time. Also, when he was wired the first time, a lot of these things were wired and then soldered in place. So like you could not remove the arms. They were all soldered in, no plugs. Same thing for the head. You could not remove the head. Once everything was in place and soldered, you could loosen them, you could move them onto the side, but they were permanently connected. So let's fix that. So in the in the new setup, I have a pair of home runs because my power switches are still on the head. So the um, the 16 gauge silicone wire that drives that powers all the motors goes all the way up into the switch, and then it's fused, and then it still goes all the way back down. The lighter gauge for the CPU, same thing, up and then back in. But now, instead of having all these power and signals and all these things for serial bus servos, I've got 3 sets. There's, for each arm in the head, there is 1 power cable and 1 USB cable. So a lot less cables, but that means I'm needing a lot more electronics. Hey, sorry, yeah, go ahead and grab a seat.
Thanks.
Versus one cable, 1 USB and 1 power versus trying to. What was the alternative?
Yeah, all the electronics were in the base. So all
Oh.
the sensors and all the motors, and because it was a smaller gauge, I wasn't using AST ST 2.54 pins. I'm sending too much current through them, probably. And so let's fix that. So now we're using a higher gauge silicone wire. We're using XT30 connectors
XT30. Those
with an updated power distribution and an XT60 for the main power. So
RC kind of remote control thing.
yeah, so standard components, they can all be unplugged.
Nice.
I end up having 5 on the power rail for the peripherals, and then 1 dedicated power rail just for the Orin with a smaller gauge. What's funny is I had originally intended to have the CPU rail be over here, but when I was looking at it upside down, I wired it backwards. So and so I was able to label it. But yeah, now there's another ground thing that, anyways, don't let perfection get in the way of getting stuff done. And I was actually thinking about, okay, why don't I just design this in KiCad and work on current power traces with ounces of tin, and like, you don't want to wait for that. So grabbed a breadboard, drilled some holes, and then solder bridged.
Nice.
And it works. And you have the cover underneath that. It's safe. It can handle all the current you need. And this is why I got the CPU rail backwards, because I knew it was supposed to be on the right, but the right is the left when you're looking at it upside down.
Yeah. This is the underside of one of those.
Yeah. This is the underside of the power distribution board.
Oh wow.
And I think I've
Never
got
used
a
those.
shot of it. Yeah, with a nice little 3D printed cover that keeps, everything safe on the inside. And as Sergey and Brian and others can attest to, fuses are your friends. The power rails are triple fused. There is a fuse that goes directly between the battery and the buck down converter. So that's the do not pass go.
Yep.
And then there are 2 additional fuse blocks in the head to protect the peripheral rail, which takes the lion's share of the current, and the CPU rail. All right. So we've got this out of the way. What else is there? So there's a recurring theme that I had mentioned earlier about finding the right boards, but then none of them having an MCU on them. And it turns out that there is an ESP32 based board with a serial bus controller, but there are no other peripheral pins. And I figured, hey, I'm already using one of these for the back. I'm using a second one for the base. Let's just, since we already have familiarity with the SDK and the coding kit for this, let's just buy a whole bunch and use them everywhere. And so that's what's going on. There's a 5th one that's already installed that controls the back, the raised lower for the shoulders. We've paired up one with the 4 driver mechanism wheel board, and so we need 3 more. We've got one for each arm, and you won't be terribly surprised when you see how these fit together in a moment. And then 1 for the head. Now the head was a little bit unique. Getting back to the space, we've got these eye lights off to the side. And in the Gen 1 hardware, those went all the way down to the base, and I was able to drive them. So he could wink and blink and also use a flashlight in a darkened room. But then when we moved to the motors with encoders, I had nowhere to connect them. So they're just unplugged. This guy right here, this assembly is going to go on the head. So somewhere, sure, yeah, if you want to pass around the tray, that's fine. Pass around the whole thing. Yeah. Throw the hand in there, Jim. I'm gonna grab 2 of these for a thing. So there's going to be an electronics box up here. And it is going, I'm going to take one of my 1 to 4 USB splitters and stuff them up in here. And that's where the microphone and the stereo camera, and there's going to be a wire up for this guy over here, and there's a 4th one I forget. So all the electronics will come up here. Also, I'm going to terminate all of those drive wires for the switches, so with a plug, so that I can actually take off the head. And that guy, I have a first draft of him. He's floating around in that bin over there, but he's not finished yet. So that's the name of the game. We'll use Raspberry Pi Zeros everywhere. We have 8 USB ports, which is just enough for all the peripherals we plug in. Wherever you see a Raspberry Pi Zero, it's going to be a micro ROS node that communicates with home base with USB over serial. These guys can support 1 megabaud easily. Oh, thank you. 1 megabaud easily. And so we've got a pretty good game plan. Now, the one of the next things, it's really minor, but is the original kit. And this is a standard base from Waveshare. And there's a cover that goes on top, and they had these M3 bolts that were screwed in through this threaded 1.5 or 2 millimeter aluminum. And they stripped up pretty quickly. So a few months ago, I expanded and tapped them to M4, and 2 of them stripped again. The challenge is there's no room behind the plate because of where the motors are. It's been bugging me for a while. So for this refit, I went ahead and drilled an M5 hole in the center where there's enough room behind it. And I JB welded a nut behind it. It's not pretty, it's not elegant, but it'll stick. And I don't have to worry about stripping it out anymore. So, I don't know if I've got that yet. But now I don't have to worry about the bottom plate bending or falling out and dropping all the electronics. Now, and another side quest on this is, yeah, you guys have heard me talk about it before, is I love carbon fiber infused PET G. It is, from a material standpoint, it is as amazing as ABS. It's strong, but it's a little bit bendy. It's pretty cheap now. And for parts that you're not going to sand and post-process or need to bond to, like functional robot parts, it's been amazing. Now, there's a new kit on the block that is even more amazinger if you can figure out how to print well with it. And that's PPA-CF, or a carbon fiber infused nylon. And it's tricky. It prints hot. You have to dry it out and keep it dry. It's hydrophilic. It'll actively pull water out of the air. So you only have a limited amount of time. If we print it over open air before you dry it again, pearls, it doesn't stick to anything. It is a beast. But when we're passing it around my little bin, you'll see I've got these tabs that I printed out. So I printed out these things a lot. And what's fun about this material is that it is within spitting distance of cast aluminum in terms of its strength. So I've got two pieces here, clanging it together. It doesn't sound quite like cast aluminum, but you can hear based on the pitch of the clang that it is very tight and it is very strong. And if you want to grab one out and try to give it a bend, this stuff is amazing. So I'm going to be trying to use this for all my structural parts. And the first one I tried to print was a new base, and it's really hard to work with, so I'm still finding it. But yeah, carbon fiber PET G is amazing. This stuff is even better if you have a printer that's enclosed with a heated build chamber and a high temp dry. There's a lot of prerequisites to get it.
What's that one called?
PPACF. This is a here, let me see if I can find it.
What's that one require? So carbon fiber PETG is fairly easily compatible with most printers.
Oh yeah, that stuff's amazing. It's super easy to work with.
Okay.
My trick right now is I always spray my build plate with a little bit of. I do still get weird stares when I buy more. But I don't worry about bed adhesion anymore, and that's even with the additional build plates and surfaces. It just works. Now, when you're printing PPACF, and I'm going to share my screen. I don't. Can I input it? There's a. So this stuff.
$75.
Yeah, so this stuff is still more expensive, and the one I'm passing around is actually even a little bit more pricey. They call it PPACF Core, and what makes this stuff special is that all the fun carbon fiber is in the inside, and then they have an outer layer of pure nylon, so it prints a little bit smoother, and the end surface a little bit smoother. And yeah, I'm looking forward to working with this stuff more. I don't think it is a replacement for like manufacturing aluminum parts, but it's within spitting distance. So I'll continue working with this stuff, and I'm definitely using this stuff when I get started on my V2 arms at some point.
It's a bit stronger, like, as you said, than the carbon fiber.
Yeah, try to bend it.
So it's
Go at it. I printed like 8 of them. You won't upset me if you accidentally break it.
that's strong.
Yeah. Yeah, it's nuts.
So how much stronger is it? Like considerably stronger than the just the carbon PETG carbon?
Yeah, the PETG carbon will bend a little bit more and will break this stuff.
No, now you're using table.
He didn't say I couldn't.
Oh. That's
Best of luck.
Probably cut my hand.
you probably cut something. Yeah, you damage yourself.
So, the power rail is in. I powered up the Orin. Nothing blew up. No fuses blew. I've got the mechanism drive wired up. That's programmed. So let's look at some of the other pieces that I'm working on. All right, so here is a draft of the head package. I personally think it's standing up a little bit too high, so I might make it wider and shorter. But this is the piece that'll sit on the back of the head that'll drive the head and light eyes, and then the 1 to 4 USB split up the top of the head. So I have one USB cable that goes up to the head, and then it branches out for all the peripherals, which will be nice. But yeah, again, it's I'm so fortunate that these folks have published files of these components, so I don't have to guess, and it doesn't take long to mock up minimal A minimal board that you have to have done in the past. Switch to that one. This guy. This guy. This guy. One for Jeff. So you're able to import their design directly in, and then you can start designing, in this case, the case pieces to fit it all together. Around it. So back over on the head. And start turning all these things off. So in the current version, we've got this nice little board base. And then that fits on top. And this isn't final. I have long since given up getting everything 100% correct on the first try. So my first goal was to get the shelves that fit. And then once I get the shelves that fit, you start thinking about wiring and wire routing and how things connect. And then that'll go back in, we'll print it. The whole thing took like 25 minutes. Cover goes on bottom. No, it's not right. Well, that's right. We're up here. So we've got the spacer on top. And then I mocked up a minimal driver board because we need that the motor driver to drive the headlamp. So that's got to fit in there somewhere. And the Raspberry Pi Zero fits on top. And then the cover. And again, as this was the first draft, I need to figure out wire routing, and then I'll print out a final, and then that will get bolted to the head.
So this is, what do you call this? What is the head supply, head control
Yeah, this is the head electronics package.
package?
Yeah, everything will plug in through there, and everything will have plugs. So like if something goes terribly wrong, like I drop it again or it falls over, for the first time, it'll actually be possible to remove the entire head. Yeah. So the next one that I'm working on is the controller assembly for the arms. So getting back with the modularity, we have a USB cable and a main power cable that routes over to the arm. And so I've got the arm guy right here. Apparently I did something and the arm brackets aren't showing up. So let's go back over to this guy right here. Oh, that's why. I was working on something and I forgot to slide the forward. All right, so this is my first generation doodle. So I'm trying to figure out how everything fits together. But if you go back over to the assembly, now you can kind of see what I'm going for. So something low profile, the USB cable will go down and plug in there. And then an 18 gauge silicone wire pairing will come through and then plug in. Here is an input, and then that power will be routed with a whole bunch of wires to feed the upper arm motors, which can be up to 4 serial bus servos, and then the elbow and wrist servos, which will be up to 3 or 4 serial bus servos, and then a third one for the hand assembly. Now, currently the hand is 1 servo, but in the next generation arm, there's going to be 6 servos. So I wanted to plan out in advance how all these things would plug together. So might as well take care of that now.
Yeah, when you're in there, as you know, when I'm doing hardware stuff, whenever you have that just everything apart and designing, you have to think about the future too.
Yeah. So I've got a game plan for all four of these assemblies. The mechanism drive assembly is done. I need to work on these next two and then get printed out, and then there's going to be a whole bunch of soldering. When I initially built Alfie, I had a problem. I had all these USB cables need to get routed, how I don't get them routed, and USB plugs are big. And that's when I think Carl pointed me in the direction of these custom USB cables.
What are the
And so it turns out you can wire your own USB cables. And so I did. I bought, I think this is 24 gauge 4-conductor wire. My convention is I always use the stripe one for ground. And this one really doesn't do it justice. This is what's connecting my 1 to 4 USB splitter into the Orin. And so with a magnifying glass, because I'm getting old, or a magnifying lens light, solder them in. And then to make sure you're using very short leads, and to make sure nothing shorts or moves, as well as strain relief, I'll just resort to hot glue.
glue gun?
Yeah, so I'll spread in some hot glue and then use a heat shrink tubing to wrap it all up. And USB-A ones are actually the easy ones. Let me see if I can find.
But the reason you did that A is it's much smaller than
Yeah, because I don't have a lot of
commercial.
And then yeah, the default one was
Even
more
the-
than an inch long. I only have an inch space.
See, I've hit this.
half.
We've all hit this problem if you use USB in your robot. Where I've never, it's like,
Yeah.
oh, well, buy some connector, some adapter. Find one in your collection that is a shorter. I noticed the commercial ones have a wide variety of sizes, and sometimes the cable can be thinner or thicker. So you have to think that.
Yeah, exactly. And so here's one of them. This one actually went back into the base. So I had already trim stripped and re-soldered and heat wrapped the 4 of those. And then what I showed you before was actually making this one shorter because I didn't have enough room for the full plug. And so that worked. And I think I had, here's an example of a USB-C connector.
Oh, the C's. You did the C's are.
And that is my thumb. So I do unashamedly use a lighted magnifying lens to solder these, but it's the same deal. Short lead, flux, pre-tin, solder, make sure nothing bridged or touched, and then hot glue, and then for strain relief and heat wrap. And it really is that simple. And that is the reason I'm able to get all these.
So even the C's are the commercial C ones are a little too big.
They're too big, yeah, and
long.
and so that's the one of the last. There's been so many, but one of the last ones is just because it's a USB-C port doesn't mean necessarily that it's actually USB-C. And what I mean by that is that is this the old one or the new one? This might be the old one. Okay. The stereo cameras that I have on top, they connect through a USB-C connector, but they're only using USB 2.0. So what that means is that all 8 of my peripherals are on the USB 2.0 bus. And so they're all sharing that same 480, I think, megabit a second bandwidth. And so you have to do a little bit of math to figure out, because I've got 2 cameras, right? One for each side, or one big camera. And then if in the new gen hardware, I end up putting small cameras in the wrists, which I'm not happy about, but everyone seems to be doing it. So, and like, oh, but they're on 2 separate USB ports on your Orin. So that, no, there's only one USB 2.0 rail, you could call it, in the entire Orin AGX. And it's shared across all of them. So It looks like I have enough for each of them. Speaking even 1 megabit serial over USB with 500 doesn't dip into that too much. It's mostly the cams. But yeah, I think everything's gonna fit. So the next steps for me are to get the cases for all these finished and then figure out how to wire them and get them installed. I've got to repin 5 USB-C connectors on one of my 1 to 4. And then once everything's wired up, we're back to systems integration. So I have to write the ROS2 code that controls the microcontrollers that allow us to communicate with all the peripherals. And then after that, I get to explore what's changed in Root N 1.7 and start collecting scenarios of grabbing cans off the floor and putting them in the trash can in time for the contest. So yeah, everything should work. It's a natural progression of everything that I've worked on before. Now everything will be completely on board, with including brains on board, including having enough room on that AGX to run like the full Quen 3.6 35B A3B model. So even intelligence will be local and it'll run at a decent clip, which I'm pretty excited about as well. So yeah, hopefully, next month, if everything goes according to plan, he will be completely assembled and the system's integrated, and we can start talking about what Root looks like with the new hardware platform. All right, yeah, I actually finished on time this time.
What was your, like, the major summary of the V1 versus V2, or from your existing one to this one? Was it like a whole rewire and new servo?
Yes, yeah. The main thing was I had to put the AGX on board,
Or EAG?
which meant that the buckdown the converter had to go inside the electronics bay, which meant there wasn't enough room for the previous electronics package. And then while I'm in there moving around the electronics, we might as well rewire the power harnesses as well to do it right. And yeah,
there's less cabling or less mess.
yeah, cables that are more appropriate to the power.
Oh, better. Yeah, they were getting too. They weren't good enough.
Yeah, and then fix a bunch of stuff that have been bugging me for a while, and you know, while you're in there.
While you're in there. Yeah, I took a similar contest on stuff or hardware. I'll do short.
Perfect. Yeah. All right. So that's all I got for this month. Thanks, everyone.
Thank you, Alan. Our second speaker is not here yet, so I guess we can take a little break. Hopefully get here before then. If not, you can do a little hardware show and tell.
What does that mean?
Oh.
Hey, no,
We can pull the show and tells earlier and we can extend them, right? So
Yeah.
it looks like you have a lot of stuff they brought in. So.
And that brings up the point. If you guys have a show and tell, let me know, and I'll add you to the list. Okay, so there's more people in now. Let's just bring up the contest. Is everybody okay by extending it for another 2 months?
Yes.
Yes.
July.
Say August. So it was supposed to be next month. So maybe September.
And then what I would suggest is, if it's September, then we're most likely definitely not doing the.
Oh yeah. Okay, so
I feel like we deprive Orange County of our phone. That's like sad.
I know it's tough. So then we're talking about October.
but I would if we can't do it September, I would put it in November, because there's people that are not going to be here.
All right. Based on all present, all in favor of moving the contest to November?
That can be like our end of the year event.
Okay.
Did you cancel out October and or whatever? I
I haven't canceled out anything, but,
Oh.
just stay
tentative,
tentative.
until we do a vote or take a, I mean, well, I guess everybody's,
I think if it's better, November
yeah.
gives us all more time to work on the robots. Okay?
But we'll check in every month to see.
Yeah.
Like,
Every month,
and like maybe October,
I'll bring it up every
maybe,
month and
please
ask
bring,
how the robot's going.
if you want, remember, you might want to test, bringing it in here or whatever you have in 1 month or 2 months before. And we can set up, at least 1 month before we can set up the arena and
Yeah.
like out, I don't
Know
know.
where Jim is?
Huh?
Have you heard from Jim?
Jim will-
Not today, but he responded to the emails and where he asked that he will be the
Yeah.
speaker. But I haven't.
But he's
talked to him
coming
today.
really.
He does.
He does come from the valley,
Yeah.
if he's coming
Oh, he's
over.
up in the valley.
Yeah, he's.
I'll give him a few minutes.
If not, I can do my show and tell.
You are first, so
Because it's more hardware still.
we can remove the 10-minute limit on the show and tells.
Yeah, I was gonna do it for 10 if it's a show and tell. I'm setting timers now, so
We have extra time if Jim
I'm
doesn't show.
gonna, from now on, I'm using a countdown clock. My computer, so I don't get.
I see some new faces. Welcome, guys. This is the Robotics Society of Southern California. We always meet on the second Saturday of every month, and we just nerd out on robots. Normally we have 2 group discussions. Like Alan did the first one, and then we have another one at 11. And it's always some robot related. It's usually something that we're working on. Yeah, it's all open to the public. Free. If you guys like what you see and want to support the club, there's an optional, completely optional, $10 a year membership fee. But again, it's completely optional. You don't have to pay anything to attend and participate in every month.
If they don't mind, I'd love to hear what you're here for, what you're interested in and what you're doing.
Yeah, so I'm currently a software engineer and I graduated the college 2024, and for my senior project I did SAE Aero, and which is another SAE competition but for RC aircraft. Most people are familiar with like Formula SAE, it's for road racing, so it's just for RC aircraft. And I was a computer science major, but I kind of like fell in love with robotics and like embedded systems doing that project. And I was already kind of interested in that, but like I made this little Arduino robot and I really loved it. And so from then on, I was like, all right, I really want to get into like embedded stuff. And I was hoping I would do, more of that at my current job, but it hasn't really like panned out the way that I wanted. So I'm trying to get do my own side projects and stuff and head in that direction, like career wise.
There's a few computer sciences here,
Yeah.
and we all kind of rotated into robotics.
Yeah.
Computer science.
A couple of EEs.
Huh?
A couple of EEs in here.
Yeah.
So if you're interested in embedded, that's a good mesh.
Yeah. So I've been trying to do like side projects on my own. I always have ideas, but I get started on things. So if I go into a group where a bunch of people are doing things, it's going to help kind of motivate
What's your favorite project right now?
I have this idea for, I don't know if you guys remember in like the 2010s, there was like the Kanye glasses, the ones that have the lines across and there's no like lens.
Yeah.
So I had this idea of doing that same thing, but making the lines real thin and then covering them in, basically covering the whole face of the glasses in neopixels, the real tiny ones, the little 1.5 millimeter squared ones, and making a whole array of neopixels and then turning that into a screen. So you could like put whatever you want on the glasses and, flash words across or GIFs or whatever. And there's already, what I'm getting into, there's already software called WLED that's I don't know if it's open source, but it's freely available and it runs on ESP32. And you can just upload it onto the ESP32, and then there's a phone app and it connects over Bluetooth and Wi-Fi or whatever, and then you can just like upload a GIF and put it on there, and it's
Rave glasses.
yeah, exactly. And so I wanted to lay out a PCB for the whole front face of the glasses and just get that made, and then put an ESP32 on the back. And
You can still see through it.
yeah, so that's the idea. I have to like do some test prints and stuff. I want to make a model, or at least do the board in KiCad, which I'm familiar with. And then I can export a 3D model of that and then 3D print it and see if like it'll fit on my face and I can see through it.
Oh, to have them cut the board for you at the manufacturer.
Yeah. So just as cut lines, cut all those little slots and
That'd be
then
really cool.
have them do the whole, layout, place components, and all that stuff is a complete module. So the idea is that I'd be able to lay out the whole front face of the glasses as a PCB, and then I don't have to do really any fabrication. I just get it manufactured as is. So that's what I do.
That'd be fun. That'd be fun.
And what's your name?
But
Spencer. Okay, that's me, Spencer. Okay.
I'm hoping to have that ready for 2 o'clock this year. So I'm trying to impose that self deadline, so I actually work on it.
And next,
My name's Miyuki. I did mechanical engineering school, and I teach at Chapman University. Do like lecturing on different subjects, and I'm going to be doing robotics this fall. So I'm trying to decide how I'm going to structure the curriculum and like what would be the most useful to introduce to students. So yeah, I don't have as strong of like a computer science background, but I've been trying to study and like learn across and stuff. And yeah, build more.
Now, Ben, you're teaching robotics, right?
I teach robotics here at university.
Yeah.
But I don't know. I think I don't know if I want to do more like industrial robotics or programming.
I also do industrial robotics here.
Yeah.
Anything you want to do, Ben?
Or like more the mechatronic side. I have a lot of like.
I teach science, robotics, and electrical engineering, industrial automation.
Oh, I don't know. Yeah, I've got a lot of electrical engineering for class. I don't know if they're gonna want to.
They like BattleBots, probably, the
Yeah.
college kids.
Yeah, I've been experimenting.
You're definitely in the right place.
Yeah, yes. Please.
And some of my former students are here, and other college students are here. You guys have met these guys, right? Do you guys want to introduce yourselves again, or I don't know if you guys ever did?
No.
You guys want to start over there in the corner?
Let's do it. We're just a student. I study here and I'm studying engineering. They have a class that's that. I think we just did that here and left on. So I'd like to be here. But you guys have to.
Cool.
Hello everyone. Been here for a little bit.
Maybe before.
My name is MJ, and I'm also go here to Cal State University Long Beach. I study engineering technology too, and I'm part of the school's BattleBots team. Is RSSC still going to the Maker Faire? And
That's what we're trying to decide, if we're gonna make the Orange County this year or not.
okay, my BattleBots team is going to be there, so if any of y'all are just swinging by, say hi.
Cool.
So I'm Carlos. I've been coming for a bit, and I have a pretty similar story. Like I just graduated here in computer science, and then I was just doing a couple projects that involved hardware and stuff. And my senior project, it was actually like an auto sorter for trash. It had recycling, compost, and trash. But we had a camera, we had a Raspberry Pi, and we had a server. So the picture would go over to the server, it would do object detection, and then send the label back. And then we had like a pivot system. So the object was there, and then it would pivot wherever the label deemed that it would go. And yeah, it was cool. It was like a group project, but I ended up being the one doing like all the hardware because I was like buying all the pieces. So I took the risk, but it was fun. So yeah, I'm just continuing learning about that, and then coming here, like there's a lot of expertise, so definitely a lot to learn from.
Yeah. Right on. So how would you sort something that was like two times?
It would default to that.
Yeah. If it didn't know exactly where to put it.
You know, we could introduce everybody in this room as far as for everybody, for the new people if you want. You know, we're still waiting for someone.
You want to start now?
Oh, okay. Yes. It's all about us. I'm retired from, I used to do mainframe computers and then I switched over to medical field of blood, kind of a blood analysis machine, which was made by Baxter. And then I went over to Alcon Surgical where we made all the products for eyes, were the depth of the eye, the sphere of the eye, doing different scans for your prescription for cataract surgery, and then the surgical equipment that would go in and it would chop out the cataract with a little ultrasonic tool that was this big, but it was attached to a large machine that the doctor would work a foot pedal. It would collect the old cataract and then slide a new cataract or a new lens in place in the eye. So that was one of our products. And then the other one was a machine that would go at the back of the eye and do, it would go in and like fix detached retinas and things like that by like a kind of a spot welding method, like cauterizing kind of thing. And so then after I retired, I got back into robotics. I used to do robotics back in the 70s and 80s. And so that's how I've been with the club now for like, I don't know, 20 years almost. So anyway, that's my background.
James, I've been coming since 2004. 2 years ago. He's from
I'm Dennis. I haven't been to a club meeting, I don't know, for like 2 years or something, because I live 70 miles away. But retired 2 years as an embedded systems developer. And now I'm trying to give back or do something for society. So I'll show in the show and tell I'm developing an educational robot. But really my main mission in life now is to do something about the impact of automation on employment. So the idea will be employee-owned companies that focus on automating you out of your job so that the proceeds of the automation go back to the people that helped create it.
Ron? Ron is our former, very long time treasurer. I'm Ben. I am the current president. President for too long.
Not long, not long enough.
I'm tiring. Brian,
They won't let me retire,
Brian.
I've got the privilege of this.
I teach robotics, mechatronics,
I'm gonna go to the board.
industrial engineering here at the university. I also, that's what I do, part-time teaching. My full-time position here at the university is software engineer and systems analyst. It is kind of why I have the keys to the building and why we meet here. Oh, there he is. Hey, yay! There's Jim. And I'll pass it on. I don't want to take too much of Jim's time. Jim, do you want to set up?
Where would you like to set up?
How much room do you need here?
Well, I gotta set up my computer.
Okay, yeah.
We have plugs ready for you.
Yeah, we've got
You
space
have
in
this
front.
table right here.
Yeah, what did you
You've
pick
got-
out space in front over there?
Oh, okay.
Gotcha.
Jim, he is one of our longtime members and today's second speaker. He is also the proponent of the current robot challenge that we're working on. Jim?
Hi, I'm Jim D'Annunzio. I've been a member since around 2015, over 10 years. And I'm a software engineer by trade. I work for, I'm still working for Samsung Research America, the research division of the TV side of the company of Samsung. And I started really getting into robotics and 3D printing in 2017. So a couple years after, attending these meetings and getting so much information, your head explodes. And then, so I have a long-term project, Big Orange, which I'll be showing some, the latest version, rebuild that I'm doing. A voice-activated AI-powered roving robot, household robot. This one project. So, and I've been vice president and president 1 year, and then vice president of the club for several years.
I'm Jim Rothrock. I'm a software engineer. But I do my work for many years in visual effects for feature films. I don't do that now. Now I do robots. The main robot I worked on was for the NASA Sample Return Robot Challenge. I don't use it anymore, but that took me a few years to film. Now I'm starting to build robots again, so I come here to learn.
I'll go. I'm Brian Erickson. I was EE in school, and then I went on to software, and so I really missed the hardware, the tinkering with things. So I got into robots. So now I do a lot of mobile robots, like take RC cars and retrofit them to be autonomous, tank treaded robot, like things that go fast, and like put different things together. So 3D printing, CNC, all those together. So enjoying this hobby.
Could someone tell me how to get onto the internet?
The Wi-Fi is.
Graduate 2574.
What are you doing?
Yeah, I do mostly software stuff. Lately, I've done more AI.
Here's the password for the
For beach guests.
speech guest. And for anybody else that needs it.
Hey, good morning, everyone. My name's Alan. I'm your club social media secretary lecturer guy.
And
I've been with the club on and off for decades now, and by trade, in my blood and my bones, I'm a systems analyst. And what that means is that anything is a problem to be solved if you stare at it long enough. So naturally, I gravitate towards robotics, electronics, hardware, software. I'm a little bit better at the hardware. I consider electronics to be a dark magic. So I am very careful to pay attention to the people in the room that are more comfortable with that. And that's one of the many benefits of hanging out with all of these smarty pants, is that I listen to what everyone does and what they're good at, because you never know when you could use some expertise. And between the meetings in person or on Zoom, as well as even in our Google groups, there's multiple active discussions usually going on at once to share what you're working on, as well as to ask for help. So my current project is Alfie. He's my kid. I went from ideating what he would look like to having him built in a couple of months, and depending on how you count, he's on either his second or third hardware generation, because much like a kid, your work is never done. After I get him wired back up and reassembled, he's going to be trained for our next contest, which is we're calling put the can in the trash, clean the room.
Clean the room again?
Or isn't that what it's called?
Yeah, clean the room was the.
Well, that was grab your cans, wasn't it? Oh, wait.
We're doing clean the room.
Wait,
Clean the room, is that what we're calling it?
Clean the room. Yeah, the can do
Okay.
challenge was the previous one.
But didn't we do the clean the room before?
Yeah, this is a repeat.
Okay.
If you want, I mean,
You still want it?
yeah, it was 2018 or something.
Yeah, all right, we call it clean the room, okay.
Yeah, so what's nice about Alfie is he's biding my time as he's waiting for and using all of the same software advances that you're seeing in humanoid robots right now. And until I decide to indebt myself with hopefully less than $20,000 or $40,000 for a humanoid, I can take advantage of those software advances with him. At his best, I'm hoping he'll be as useful as a 5 or a 6-year-old, limited only by the processing hardware on him and how tall he is, because he's kind of short. So that's my story. All right, I think that covers.
Back to Seth.
Oh, yeah, Seth.
Oh, yeah, you missed Seth. So,
Finish. Yeah, okay, I'm Seth. I mostly do software stuff, just programming. Lately I've been very into LLMs. I've been learning a lot about training LLMs and stuff. Trying to see how much I can do without buying more hardware. Most of what I do now.
And you can run on your phone, on your.
Oh yeah.
Seth is also one of our youngest members.
Yeah.
If not the youngest. Because I think.
We don't have our set 8-year-old anymore, right?
No, Seth probably is the youngest member.
Yeah.
thank you. Comfort.
Justin.
Justin.
Justin, show up sometimes.
We have a question.
I think Jim is almost ready.
Yeah,
Yeah, every once in a while, it's good to do introductions, like at least once a
We have new faces.
new faces, yeah.
Take 15 minutes.
It's not our zoo.
Find out what they're doing.
Contest.
Yeah, but
There's still time.
yeah.
Robot, at the center of a box, we have a box that's marked off with black tape. And it's supposed to go and get cans and throw them either in a trash can. That's reserved as a trash can, which will be a box that's outlined in black tape. In the hallway up here.
All right, Jim is all ready to go. So Jim, we appreciate you sharing a talk with us. The floor is yours. Why is that?
What's happening?
Oh.
Yes, that's your Zoom toolbar. That's to control whether you can move it around to get it out of the way.
Okay. Okay, here I am. Can everyone hear me?
Yes.
Okay, because sometimes if I have a tendency to suddenly start talking real quiet, come over here and kick me in the shoulder.
Jim, if you want to introduce yourself
I am James Huber-Sutzig. I've been doing this for a long, long time. And I started just building different kinds of robots for contests. But then I got the idea that I could do more. And that's kind of what this presentation is about.
So, let me just mention a few things. Basically, I'm going to talk about how I got started, how I produced a baseline design, which is an overall design for an autonomous home robot, which I really, really, really want to build, how I have then prototyped the subsystems, my multitude of robot hand designs that I built the prototype, brought here and demonstrated. Where am I? Why doesn't it go one chart? Okay. When I graduated from the university with a bachelor's degree in electronics engineering, I was required to get that degree to take these core courses in mechanical engineering. Statics, dynamics, material science, design of machine elements, strength of materials.
Good stuff.
And to complete the electronic homework assignments, I had to use a multitude of computer programming languages, which I knew nothing about. They had just assumed that when I arrived at the university, I already knew how to program computers. So I quickly learned how, and I learned how to design and write source code. And that's why it's so easy now for me to write software for my robots. But when I graduated, I was of the opinion, and I told the recruiters who were thinking about hiring me, that I have equal skill in software engineering, mechanical engineering, and electronics engineering. A big company hired me, Lockheed. And as soon as I started working there and started working on software and mechanical engineering, they called me into the office and told me, no, that's against the union rules. And we hire only on the basis of paper credentials. You don't have any paper credentials for software engineering or for mechanical engineering. You're only going to be allowed to do electronic engineering work. So gradually, I took my special skills home and used them on my own engineering projects. At home is where I did the real engineering, you see. But I worked there for 28 years, and I'm retired from there now. So and it paid good. It just wouldn't let me do what I wanted to do. What I love to do is use electronics engineering, mechanical engineering, software engineering. This is me, all in one project. And I discovered that autonomous robotics requires all three. That was my true calling, and that's why I joined this organization, the Robotics Society. I had this idea for an autonomous servant robot. So I gathered together all sorts of papers on mechanical designs, other people's robot designs, especially hand designs. I really liked the Salisbury hand, if you've ever seen that one. I had a big table, so I spread all the papers out, and for months, when I had spare time, I would rearrange the papers, trying to match things up. Suddenly it all crystallized, and I had my baseline design, which is called the Baseline Design for Home Robot. At the November 1995 and March 2001 RSSC meetings, I gave away copies to everybody, printed copies, talked about it, promoted it. When I taught 12 sessions, one at each meeting, at a robot design class in 2003, that same baseline design was the class textbook. Now, let's see. Nope. What happened?
There was a pop-up said, the pop-up said application
It
closed.
looks like you're fine. Still see you.
Be something on here that lets this display large, but I don't see it. Well, maybe I see it here. Okay, I'm looking there, but it doesn't show exactly the same thing that's shown here. Okay, here's the baseline design. Now, published this thing a long time ago. The idea of it was twofold. First, to come up with real numbers that can be used for building the robot, definite numerical values. I looked at the latest USA Census information, and they said that if a family has at least one minor child, there's about 5 hours of housework each day. I'm not sure if that's true, but I assume that gives me a number. Whatever I build, it should operate without requiring a new battery charge for 5 hours continuously each day. So there's a number. This is just a list of things that, in my wild imagination, it would be easy to have the robot do. But I assume that the robot would use the appliances that are already in the house. So I need to have a very capable hand on it. I measured doorways, and I talked to one of the members here, Don Fears, who was a professional architect. And he said the robot should not be taller than 74 inches because it has to pass through a typical doorway in your home. And similarly, if you want the robot to clean your bathroom, it's usually the bathroom doors that are the narrowest. And according to our friend, Don Fears, the doorway can be as narrow as 24 inches. So I figured there's also the hinging of the door. You really only have about 21 inches. If your robot is no wider than 18 inches, then a navigation error to go through that door is plus or minus 1.5 inches. So see, now I've got another number.
That's tight, Jim. That's tight.
That's tight. So it might be you'll have to clean the bathroom yourself, or it'll solve the navigation problem within 1.5 inches. Oops, wrong thing. I keep looking at that when I should look at this. Okay, I decided that, talking to some friends of mine who were attorneys, that it's a really bad idea to have your robot climb up and down stairs. Because the first time that a robot comes tumbling down the stairway and there's a small child playing on the steps and the child is smashed, the whole industry will be shut down. So I decided if you have 2 stories, you should just buy another robot for the second floor. I'm not going to build something that will climb stairs. Other considerations in your home are that you should limit the available force applied by the robot to no more than maybe a 90-pound child, because you don't want it to knock people down. And I estimated elsewhere in this document, where you'll see it, that an experimental model might weigh more than 150 pounds, but I thought that a production design would weigh about 150 pounds. So I had this little cart about that tall that I got at Harbor Freight. It has caster wheels, and I piled it high with 150 pounds of stuff. Then I attached a rope with a spring scale, and I measured how much force it takes on thick shag carpet to make it start rolling. I needed 50 pounds of pull, figuring about 1 foot per second so people have a chance to get out of the way of the robot. It works out to 1/10 horsepower. So now we've got another figure. For propulsion, it needs 1/10 of a horsepower. So the whole idea here is to work out for the individual subsystems like propulsion. In this case, you need 1/10 horsepower of propulsion. And for other subsystems, once I have enough numbers, I can build the subsystems one at a time, and hopefully everything will fit together very nicely and work. That was my idea. I decided it should have long arms so that a robot could make a bed just standing in one spot. And similarly could make the table where you eat, set out the food. That would require very long arms. Now, this section here, this section needs to be rewritten, this one paragraph here, because I want to use the newer design batteries. This is old lead acid batteries where they've gelled the electrolytes, but I want to find out from the people here who have used rechargeable lithium technology batteries what the different chemistries are and what works reliably, particularly unattended. I don't want the battery to leak or suddenly ignite, because those lithium batteries can ignite. Some of them definitely can. Then in that case, I'll replace this paragraph. But the requirement remains the same. You need about 1,000 watt hours of energy stored, because divided by 5 hours of work each day, it gives you about 200 watts on an average. And that's actually about what you need. Take the 1/10 horsepower requirement for propulsion, that's about half of it right there. And the other half would be for everything else in the robot, which would probably be smaller motors. Some motors will require reversing, and that's easy to do. And I like the idea here that automobile parts, you could go to a junkyard called Pick Your Part. You can go in there with a toolbox, remove anything you want, which in this case would be like the accessory motors, like power window motors, power door locks, power seats. There's all kinds of motors in cars, and they all run on 12 volts. Now, if I figure some of these lithium batteries, are they not like about 3 volts per cell? Anybody know?
3.7 nominal.
3.7? Well, 4 of them then would give you about a little over 12 volts, which is the number here. And all of the stuff in the gasoline powered cars is 12 volts. So now you can use a lot of that stuff. If you wanted a production model, you probably would contact the manufacturer of the replacement part and say, I need 10,000 of these next week or next month or something. But for prototyping, you can get them for a lot less. That's kind of the concept here. If it was 14 volts, it'll still work, because like your car, when the engine's running, if you measure the voltage across the battery, it's 14 volts. It's a 12-volt battery, but it's being charged all the time. It's actually got about 14 volts. So if you could match that with the lithium, you'd be okay. It's going to have a reel. I will show you an example of the reel. I could show you a bigger one. I'm going to pass this around. This is a little tiny version of it, but it pulls out and it rolls back up. The idea is to have a retractable reel, much bigger than that, because it'll have a power plug to plug in the wall. Somewhere in the base, there'll be a big reel. I have now a 25-year-old. It still works great vacuum cleaner, a canister style, and it has exactly that. I took the bottom off to see how it works. It's the same mechanism. Somebody sells that replacement part. We could buy that and install that in our robots, so they could easily grab a plug, unreel it, plug it in, and when they let go, it rolls back up. So here's a sort of a diagram of how that might work. Here's your automatic cord winder, something that would then convert it into basically a battery charger to keep the batteries charged. Here's the left and right motors, the heaviest and strongest motors to make the thing roll. It's a very simple idea. Now for navigation, my first idea, published here, was to have this barcode. I'm not going to do it this way because I came up with a better idea. But the idea at the time is that it would be a 12-bit code. If this is on the floor and the robot rolls to here, this is maybe about, an inch and a half or so. By the way, the plus and minus inch and a half for navigation. If it rolls to the center, it'll be within plus or minus an inch and a half, which is close enough. You can have one of these on each side of the doorway. It's 12-bit code. The first 2 lines are just calibration, so it knows how wide it should be for a logic 0. This wide one is a logic 1, 0, 0, wide one is a 1, narrow, wide one is a 1, 1, 0. You reach 12 bits before it gets to the center. 12 bits gives you 4,000 codes, which is more than you will need even if you have a huge mansion of a house. But I decided this might be good for certain things, but I'm going to use my circular navigating system. You might have all seen that. I bring in the robot for that sometimes for contests, and it navigates quite accurately. It localizes itself within about an inch in a typical room. It doesn't need any of these. So I might take this section out. I'm not sure, but just an idea. How am I doing on time?
We're at
33.
Yeah. About 20 more minutes.
Okay.
Yeah, we're doing good.
Okay, now I'm talking here about other sensors for navigation. The magnetic compass, which you should have the magnetic compass way far off the floor, I've discovered, because a lot of rooms have concrete floors, and in concrete is rebar, which gradually becomes a permanent magnet, and the compass just points to the rebar. So you'd want it high up if you're the magnetic.
Right, it looks like
What
you've
happened?
been disconnected from Zoom. Are you still on Zoom?
I don't know. Well, I got something here that says Zoom workspace, and it says connecting. There's a little symbol spinning around and around. What does that mean?
Still good. What?
I don't know. Let's see. It says beach guests, so I assume I'm still connected. What is going on? What do I need to do?
All right, let's see.
This thing says, whoops, this says beach.
Yeah, what's up here?
Just
Yeah.
yeah. I don't think that.
Let's right click and we're breaking from which. What's that? We always call that. No, or it's the earthquake sign. It's not, yeah. Yeah, I do that.
And then so I get you to your arm.
I can feel the touching. So that,
I can actually feel them hurting my, I'd rather just have it.
Yeah. But it's so better.
16 hertz. It's messing your brain up. Yeah, you feel better like this. It's the rest. Oh, you can.
Other way you could use.
Yeah, that's true.
So I think it's.
Trying to figure out. I think I should just bring in everybody that's solar lamp, portable lamps. The next warm, like warm.
You get the sunlight. You don't get. You never get sunlight, right?
Hey, Les,
No, but
your hand up. You got a question?
Go look at. We have to modify the bill last time we went. How about a year, some years, so maybe into the door.
That's pretty cool.
That was
All right. And then you can sell this for solar.
Yeah.
Yeah.
Let's drink this guy out.
That's a big problem. Those solar.
Well, they do that. The ones with the salt.
Yeah, the salt. Maybe they need a new design for bigger plants.
They're big. The heating it up is too bright. So when you're driving by it, you're blinded by it. I'm not literally blinded. It's too bright.
Yeah, for people, for humans.
Yeah.
Oh, because it's.
They're already black, but it's still super bright. I mean, it's they're black.
So have you, I've seen those from airplanes, but I've never driven, or driving to Vegas.
The division, but it was a lot of that.
Yeah, you'll have this dot in your eye for this color. Yeah. Because I haven't been to Vegas, recently, or with my wife wants to go. I just saw an article that's a whole trade show in the bus in here on kind of places you could stop on the way to Vegas, like off.
Yeah, like Magic Mountain.
Oh, but not wrong.
No.
Seriously?
Oh, it's like the thick figures. No, not rock.
Oh, the tall rocks?
Not Six Flags. No.
I don't know the names, but I just know they're all painted different colors.
The rock?
Red Rock?
Stack rock.
Unnecessary.
Oh.
Okay, see that one I didn't know about.
And there's also.
Looks like the real.
Oh.
It's gonna be learning circles. Yeah, all linear.
There's an actual roller coaster on the way.
Oh, really? Right?
Or it's on the way to Arizona.
It's not very big, it's right.
Yeah.
I don't know if it's still open, just there's only one.
Been there in a long time.
I haven't, you generally don't go through the, unless it's a last.
Cool thing in Vegas that we're eventually gonna do is pay to ride bulldozer or something.
Yeah.
Like, you can go there. Yeah, and if you have a bigger group, you can, it's like a. It's a lot of money, it's like $300, but like, it's so. You know that too,
Yeah.
I have that as well.
And then there's like a Humvee tour, so that's kind of fun.
Oh,
My turn. Yeah, so then like. Yeah, I think we get a lot of. We have like. Oh, what you're.
And shoot, or shoot, I mean.
I don't know if that's, I'm not really sure related.
Oh, okay, separate.
Yeah, it mills and it chops out the cataract, but.
Oh, so you make passes on the.
It's like ultrasound.
Yeah, like.
Oh, it's off the road.
Chop it up and there's small fragments and then vacuum clean.
Okay. I don't generally don't, but off the road, I want to scenery.
Yeah. Let's go.
Jim, you're back on board. Let's do this.
Okay, let's continue.
Oh, without any, oh, it's your choice.
All right, so Jim, where did we leave off?
Okay, now, this is just about propulsion, which is very, very simple. It's just a simple differential drive robot with one modification. It's got thick wheels on the outside, which are for propulsion. And in here, it's got wheels that are just like have an O-ring and they're sprung down against the floor. Those are the odometry wheels. They're separate because sometimes the propulsion wheels will like slip. But I want to know how far the robot actually moves. So I've got separate wheels just for odometry. They're just like ball bearing wheels that freewheel. That's really all this chart is about. It's, a way of doing this. But that's basically just a differential drive base. This, however, is more important. I'm making the point here that the fingers are the essential functional parts of the robot. I'm proposing a human-sized robot hand with 3 fingers but 2 thumbs, like this. Nobody else can see it on Zoom, but the idea is that the thumbs don't have to move this way. It's simpler mechanism. Each thumb, which is wider, tries to go between 2 fingers, but it can't. So you can therefore, with any thumb, oppose any finger. So it's like a right hand and a left hand at the same time. If you only need a right hand, pivot for that thumb would just hold back all the way against the wrist. It only needs 1 thumb for a certain task. So that's just my idea. How well that will work? Seems like I brought that in once and demonstrated that here years ago, a model of that. So that's something. Paint and film sensors for the tactile sense. Now to get the long arms, I'm figuring 2 segments that are 3 feet long. And I want them to be lightweight. I want all the heavy stuff, the batteries, the heavy motors, and the base, so the thing won't tip over. But the idea of this is down in the base, there would be 3 motorized drums that also measure the tension in the cables. So one arm segment would go from here to here, and one arm segment from here to here, which is where the wrist and the hand would be. By turning these select cables out and wind them back in, you can get all these different motions by running each motor in different directions. Raise, lower the wrist, move all the different joints of the arm with just 3 motors. Thought that was a nice way to do things. So that's what that chart is about. Now, here, it just illustrates one way that you might make that motorized drum. To pull the cable, I way down draw this thing. There's 2 shaft encoders, one here and one here. This shaft encoder measures the actual rotation of the drum. But there's a spring from these pin to this pin, and the rest of this is like freewheeling and turned by the motor. So what happens is the more tension there is in the cable, the longer that spring will stretch. By subtracting the counts from this shaft encoder from the counts of this shaft encoder, the robot can know how much tension there is in the cable. That's my theory. I haven't built one of those yet. Anyone want to predict whether it would work or not? The reason I want to know the tension in the cable is that gives me a clue about how much force is being lifted by the arm. And if it's trying to lift something really heavy, like a bowling ball, when it's stretched out the full 6 feet, it probably will tip it over at the base.
6 feet arms.
Yeah, because each segment of the arm is 3 feet. Yes. And here is an end view of the arm. So I'm going to pass around. I built this prototype.
This actually, or
This is well, the purpose. Yeah, there's stuff inside. It's this diagram here. There's going to be the inner piece of tubing, which would be the structure for the arm, and you can run the cables inside that. Then it's got 4 push button switches, each with like a spring to make the button push out when the button's not pushed. And then this outer piece is the bumper shell. If the arm gets bumped, or if the arm's moving and it bumps into something, it pushes at least one of these switches. There's 4 switches at one end, and there's 4 switches at the other end. So it takes like a byte, or you need about 8 GPIO pins for this. The idea is to have a kind of a sense of touch, at least in terms of being bumping into something for the arm. So each segment of the arm would have one of these. The mobility base should have another shell like that that floats on the push button switches, so that if it gets bumped, the machine would know it. That's kind of the general idea of this chart. It's just discussing these floating bumper shells that I just talked about. The eye of the robot, the sensors are now so cheap It will just have an eye every place on the robot where it needs one. Like some of these notebook computers, you can have multiple cameras and there's a way to switch between them. It'd be something like that. But one of them we need is a curvature sensor. Basically, it measures things further away and gives it a clue. Is it like a corner? Like the corner of a room? Like this? Or it could be the corner between a floor and a wall. Is it curved one way or the other? And it's for like things that are further away. Another version of this that needs to be on the robot, I'm calling a solid shape sensor. It does the same thing, but it's for things right like in front of the hand. What shape is it? So that the hand can pre-shape accurately before it tries to grab something. Now, this method, I was using like a laser that goes through a glass rod and makes like a stripe. And then there's a video camera that looks at the pattern that's on the surface. But I don't think I do it that way. Just recently, I bought from DF Robots. I bought 2 of these little sensors. They're time-of-flight sensors with 64 optical beams. I hope somebody here has used that and can show me how to get the darn thing working. Because I got to figure out how to interface it to like a miniature computer, you know, that'll fit in the robot. Because I'm going to get 64 numbers. There's like 8 rows and 8 columns of beams. They're all infrared, I think. And I'm going to get all these distances. So if I want to know what shape the hand should be to grab that thing on the table, if I put that on the wrist or someplace in the hand, and get all those distances, I have 64 numbers. I should be able to get a rough idea what shape the thing is and pre-shape the hand ahead of the time before the hand reaches over there to grab it. That's my plan. I also plan to use barcodes. A lot of products at stores have barcodes. And I'm planning to have a long-range barcode scanner that can like scan all the way across the room. And it would just return to the main computer in the robot a list of all these barcodes and at what azimuth and elevation it is to each one. So that if you have told the robot somehow that it's supposed to go do something with that, it'll know roughly where the thing is. Of course, sometimes things are turned around where you can't see the barcode. But if your robot's not doing anything else, I'll program it to just go over there and turn things around until the barcode shows. So when you look in your refrigerator, you'll see nothing but barcodes if the robot's been in there. And I'll have a short-range barcode scanner on the hand, so that as the hand's getting close to something, it can have some terminal guidance and home in on the thing that it's about to grab.
That could be much simpler today using a camera.
Barcodes. But we all know what the barcodes look like. The 0 usually means it was issued in the United States. The 2 is a checksum to make sure you read the rest of it okay. Any laser that just stripes through there can read it. It can be any angle, like a big diagonal angle, as long as it goes through all of them. So like at the supermarkets and other things, that's all they're doing. They're just having a laser beam that zips through it. They don't actually read the number that's printed there. The first 5 digits is the manufacturer, and the next group of 5 digits is the code. So that's enough for what? 10,000 or 100,000 products, all by the same manufacturer. That's way too many. There's hardly any company that makes 100,000 different products. But there's enough codes. This is something I thought of for like a dinner plate or something you're going to put on the table. It could look like it's decorative, like just lines that go around in a circle, but it would actually be a barcode similar to the one I was thinking about for the floor. It would just identify it as like, you know, a 9-inch dinner plate or something. So the machine could figure it out without too much trouble. The last thing is the very important chart, or the last page. All of the things that are talked about in here are now indexed. So What is this thing? Where did it come from? Well, whatever. Basically, the motorized base contains all these things. So like 1.8 is the floating bumper shell, and if it has infrared distance sensors, they're all there. The arm unit has many, many, many parts. So like 2.9 is the hand. 2.9.2 is the slip sensor, and so forth. They're all indexed here. And then the 3 points are like internal software modules. I've got them all listed. They all have to be written by somebody. That will take time. So that's it. That's all we have here in regard to the actual baseline design. And so, let me go back to this thing. Where is this thing? Oh. All right. Now, I'll try to wrap this up fast here. Based on this design, I built all kinds of subsystems that are prototypes. The one I just passed around is a floating bumper shell. When I was teaching the class, I gave a homework assignment to have students try to build something that will reliably detect that a grasped object is slipping out of the grasp of the robot. The guy who won that is Jess Jackson. But just going through some of these, slip sensor, he came in, he really knows a lot about making things like hollow out of fiberglass. So he built a hollow fiberglass hand. He put in there the spring from a ballpoint pen and shoved into that the eraser from a mechanical pencil. And that's like one electrical wire of the sensor. And then he had it pass through this brass washer. Now the object being grasped will tend to drag on this rubber eraser, which has good traction on all kinds of surfaces. So if the object is slipping out of the grasp going down this way, it bends this whole thing with the spring over and makes contact with the brass washer. It's an electrical switch. After we demonstrated it, I asked if I could test it, and I discovered it's remarkably reliable. And you can just use dollar store parts. You can get like a pack of 6 ballpoint pens with a button and a pack of like 5 or 6 mechanical pencils. And you can build yourself 5 of these sensors. You just take the spring from the ballpoint pen and the eraser from the mechanical, and it's a perfect tight fit. You shove it in there, and it's got a really good grip with the spring on the eraser.
What's the sensor mechanism though that's built? How does it convert to electronic energy?
Well, you just put a voltage across it. It's just an electrical switch. If it moves far enough for the, if the spring bends over far enough because of the friction between the rubber and the grasped object, so that it touches the brass washer, because this is one electrical wire, the brass washer, and the spring is the other electrical wire of the switch. So if it moves in any direction far enough, it's going to make contact. So you can just use one general purpose IO pin. You need maybe a pull-up resistor or something so that it voltage changes. Another one mentioned is item 2.9.4, the modular finger. I built these modular fingers. I built 5 or 6 of these. This is the one I could find fastest last night. It's basically a finger. It's got a servo mechanism, mini size. I think this is an HS-84MG. It's got metal gears. It pulls this tendon, which makes the finger flex. And it, because of the plastic tubing I'm using, is springy. It'll spring back approximately straight like this all by itself. It has tactile sensors here, here, and here. It has a proximity sensor it indicates there's something near the fingertip, which is going to be really useful when it's trying to grope around and figure out how to grab something. Because if you have a proximity sensor at the end of each fingertip, it tells the machine something about, is there something there that I could grasp, and maybe a clue how to grasp. And I'm going to pass that. Here's the modular finger. The dimensions are off my own hand. I just used my longest finger. Got the place for the joints and the dimensions. But if your eyeball was here and you were looking at the finger this way, you would see that surface, which looks like this. There's a sensor across the top of it. It's a flex sensor. It's a resistor. It has two terminals. It's about 60,000 ohms until it starts to bend. It's measuring the bend of the finger. As it bends, the resistance increases and increases up to like 200,000 ohms or something. I'm going to pass one around. I would suggest don't like crease it like a piece of paper because it'll bust and never work again. But I'll pass one around so you can see what the thing looks like. A flex sensor. Okay, I've been working on these software modules for the machine's internal computer, and this is very near the end of the presentation. The list of all of the different software modules shows a hierarchical planner that would decompose what it's trying to do into subtasks and then a subtask sequencer. But I built so many robots for the contest that use Rodney Burke's subsumption architecture, and it seems to work remarkably well. It doesn't really do any decomposing of tasks that is explicit. So I might replace 3.3 and 3.4 with just using Rodney Burke's subsumption architecture. I've never used it, though, on such a complicated machine as the one I'm describing. So I'm not sure how well it will work on an extremely complex robot. Does anyone have any opinions about that?
I've never heard of the Rodney Burke section architecture.
Well, he and his team at MIT in the robotics lab, they built something called Attila, and there was some other one that was six-legged robot. And they used the subsumption architecture. And then later, when he started his own company to build like a robot with two big arms for like working at factories, he used the same subsumption architecture. What was the name of that company?
Well, the robot was Baxter.
Yeah, Baxter. Baxter used the subsumption architecture.
Just rethink robotics.
Yeah, that's the one. Yeah.
Yeah, that was a horrible robot.
It might be, but it used the subsumption architecture.
Now that we're nearing the top of the hour.
Yeah, right near that. So I'm going to wrap this up. If you want to read about the circular navigating system, I think it's on our website, rssc.org. These three issues of the Robot Builder tells you how to build my circular navigation system. That's what I'm proposing to use now. The reach for grasp subsystem basically just establishes priorities. Once it knows what it's supposed to grasp, it has these modules. But basically, the hand just simply tries to grab whatever it is. If the hand can't pivot far enough at the wrist, it sends a message to the software for the arm, and the arm, being 6 feet long, tries to reach over to where the hand can grab the thing. If the arm still can't reach it, the arm sends a message command to the mobility base to roll in that direction. So it's a very simple concept. Don't know how well it'll work, but the idea is one way or the other, the requirements of the hand drives everything else in the robot. I've seen all kinds of hands that I have prototyped and built because I bring them to meetings and demonstrate. This one was at 1, 2, 3, 4 different meetings, my 7-panel hand. The modular hand just means it was made out of those modular features, the one that I'm passing around. One of them was cone-shaped. And one of them is the one I mentioned in baseline design, which is 3 fingers and 2 thumbs. That works remarkably well. And other hands. At this point, I'd appreciate if you have any questions, because this is the last chart. I need some support from this organization. I need contests where I need to demonstrate some of these subsystems or assemblies that are listed on that chart. Because I need some motivation to really make this thing work.
How about using your 2 thumbs, 3 finger hand for the CAN project, the contest that ones we're working on?
Well, that's a possibility. I also need information. I don't want to know manufacturing claims for the manufacturers because they lie. But people that have direct experience using these lithium rechargeable batteries, if any of you can give me clues, because I want to rewrite that section of it, and I want to make sure that the batteries that I specify, are reliable for use in the house when like nobody's at home and the robot's performing tasks. I don't want the battery to leak or ignite or something.
Nearly everything uses these little 18650 lithium ion batteries. You've got tons of stuff in your house that already uses that.
Oh, really?
They don't leak. If you get a decent manufacturer like Samsung or Sony or something like that.
Maybe I should write that down.
The specs on it will be real.
So what's the number of it?
18650. It stands for the size of the battery.
18650.
Yeah. If you go to a reputable manufacturer, these are the lithium ion. I mean, not totally safe. No battery's totally safe because they have energy in them, right? But,
well, I mean, if somebody's gonna like with a hammer and drive a nail through it, then I guess it's safe if it ignites or something. But it just normal use.
Yeah, it doesn't leak. It doesn't auto catch fire. It can handle
The
decent
lithium
temperature range.
batteries.
Yeah, and then I'll show you, in my show and tell, I'll show you some battery packs that use those internally.
Yeah.
That
So-
add to it, a battery management on top of that.
Yeah.
And outputs and it's a consumer.
That's
product.
exactly what I need to know because I need to rewrite that section of the baseline plan.
Yeah,
I'm using them in mine and it's all managed.
So you take these little cells
Uh-huh.
and you put them in series or parallel to get whatever you need. I think in Alan's robot there, that backpack you've got is just a bunch of 18650s inside of it, the bicycle. It has to be, yeah. They almost always are. And Teslas, we're using those until resell them.
So
Yeah. Then they changed it recently to a bigger cell, I think.
Over the bike, e-bike.
But they've got good energy density. They're fairly light.
And you can either do your own management system or buy existing consumer grade packs.
Usually they have
raw
BMS
packs.
in.
Some of them do, not all of them. The ones that are slightly longer that have a little thing at the top have a BMS built in or protection, and other ones are raw for people that want to create their own battery pack. But I don't recommend that. I've never needed to. I buy consumer battery packs.
How many of these would I need to satisfy the numerical requirement, which is 1,000 watt-hours of energy?
Yeah, I was going to tell you I can tell you at the show and tell, but
okay.
Mine, yeah, I'll tell you what I have so far, and it's not quite what you need, but it's getting some.
Each cell would be like 2,000 to 3,000 milliamp hours. So you can do the math. Assume 3.7 volts.
I have 12 in each battery. And
is it safe to wire them in parallel, or should they?
Yeah, you can do.
Yeah,
you do series and parallel
first, so that you can put it in parallel.
Like mine, the battery pack I have has 3 times 4, basically.
Okay.
To get the 12.
Yeah, but I think you're right. You just buy a pack.
I buy the pack.
The packs already exist. Buy a pack with a BMS even.
And then it has a consumer thing you can plug in the wall.
Okay.
And then you can change that to a charge port.
Mm-hmm.
And they're a lot lighter than the lead acid because those are real heavy.
A lot lighter for the energy.
Well, I'd like to reduce the required weight of this from the 150 pound, which was based on the lead acid, down
Yeah.
to something you could do with the lithium. It doesn't have to weigh.
That battery right there will charge a bike with a human on it for what, hours? At, what do they look?
Ferrite batteries will weigh about,
Yeah, that guy can run 4 to 8 hours. Like that battery's so provisioned for it.
Yeah.
Wow. Yeah, the one I have is small. The pack I have 2 packs. It's a little smaller, and by my calculation, the robot could operate for like 2.5 hours, 2.5, 3 hours moving around with mixed use with an arm and moving and all that. And compute. There's a lot of compute with AI and stuff. Compute uses a lot of power too.
I hope that my presentation will be part of the video for this meeting.
Yeah. Oh yeah, it's all recorded.
Okay, good. Well, I'm basically finished unless somebody wants to comment on anything.
With that, let's break for lunch and come back at 12:45. And for anybody else that has a show with them, let me know so I can add anything to the list.
Let's go to the corner.
Yeah. Yeah, I had the rest of it.
All right. Wonders where 7-Eleven is, 7-Eleven, the Chinese place, Mexican place, or Mexican place. And then if you go down the other way and to what is that? Left, there's a diner there. Okay. Okay. The closest would be the corner here. The piece of
Okay. Basically, just wanted people to understand.
Thank you.
Is the paper listed anywhere?
I gave out printed copies all over the place, but once they put the video on the meeting together, why didn't you pause it anyway?
Actually, middle of
I guess I didn't exist when you originally threw those papers.
Kids that I've been using.
Well, no, that's understandable.
Little.
Anyway, it'll all be there in the video.
So,
Make a pause and
everyone needs to do that.
You can do them all.
Robots.
For your
And the robots like that. I go over it. I try to keep it as light as possible. The robotics class is kind of like intro class, so it doesn't go too deep into robotics. But I do go over the rocks. Most of the labs are Arduino. Yeah. Yeah.
yeah. It's part of like
I teach under electrical engineering. Sorry. Under electrical engineering here, there's 2, I guess, little sister programs. One of them is engineering technology. Computer engineering technology. That's what I was talking about.
The DFA.
Yeah. Have you seen it on the?
No, I haven't.
So,
No.
so your revised class
They're
one.
not chili. They like not much. They were like about $22 or something.
It's bad. What's it like to use? Say by the time they get there, they have to know like all of the basic stuff. It's a upper division class. So
I wouldn't like about but 40 updates per second measures like
That's the first time they're just
64.
Oh,
that's very good.
However,
I should be the person to be
work with any miniature computers.
just in case.
Oh, like there's a miniature computer here on the side of the computer. It's like seeing this little one here. Its idea is to integrate, all the stuff that work.
I use
Like
the
how much
same
computation power would you need for this?
they have to.
And each finger would have one. There'd be an interfere bus, which is what these wires are.
And since they're like electrical engineers.
So they can talk, fingers can talk
like
to each other.
CAD or
They, for my class, they do have
that computer.
it has, because it's part of the whole,
That,
you know,
that's something
the class have to be able to design their own stuff.
Keyboard, this basis.
So most of them already have some kind of CAD
You know what?
design class that they've taken. So
You have to
I've never had
have a pretty high
semester where nobody goes
term for it. It's like clock speed.
Yeah,
you just kind of like submit a salary, but I have to take it
know
all
exactly
other
how that
classes.
works,
So
but it's
correct
like
before that.
many.
So they know how to 3D model,
Gonna have to figure that one out.
all that other stuff.
There's some little solder blobs there where you can change the
In our
insert.
class, like one of the lower divisions,
Upper division.
Something that came.
So I kind of
believe
want
so.
to write
That's
so I have these like robot arms, like put on the shelf. And then focus more on like rush events, the computer vision. And I have them so that like like
Oh, I was looking at commenting on the Japanese side.
and so yeah, it would like they have to do the camera vision and there's like it's on their side.
Yeah, what's in there?
Like the logic.
I don't know where he's to your
These are these look like they're made, they just like one GPIO. Maybe they're just get on one of them. Yeah.
That makes sense.
you have them go through the University of Athletics, right?
Like I do. But like I don't really like
Was it like
the
where the
the
other
like
showed it up?
back
Like
to
a few
come
months
the
ago?
robot like as
I know Arduino has like
you know, like it's like
supports an operating system. It has a higher clock speed than the baseline Arduino had.
Gotcha.
So like move it there, this is the pickup spot.
I believe it's the new one is called the Uno
Like
Q.
pickup pose, I'm gonna have like a
Yeah.
like I'm gonna come right above it, so this will just be.
Well, what is
It'll
everything
be
on the
Arduino Uno Q.
Grab it, come back up, then drop it, like you don't have to just like.
It's in the same form factor as the Arduino Uno, but it has like a single board computer built into it that can like support Linux. It has like 2 gigabytes of RAM, 4 gigabytes of RAM,
They have to like do.
and a higher clock speed.
Yeah, that's part of it. That's the second half, so I think that is included in the final. I don't give them like a really complex arm, it's just a two.
So it's the same form
So
factor,
it's
but
just simplify the math.
some way.
It can get pretty
Yeah,
crazy if you go beyond that.
Really
But yeah, I do test a lot.
different product. It's a little surprising they still call it like a Uno Q.
They're robots.
Yeah, I mean, I guess if you're designing your own.
Okay, you
Yeah,
can see where I'm
vibrant.
coming from. If I can give all the data,
There is, but
I write something in the software that
have
has
to do it
shapes,
by hand.
just cylinder shape, ball shape,
Get
different
Get
shapes.
to know what happens
Things
by
like
what's
house,
happening.
Right.
Yeah.
so that it can kind of get a rough feel.
And you just gotta go.
And if someone comes to the hand,
Oh.
maybe in the palm of the hand, it'll fit in there. Just coming up with something to appreciate, even by appropriate, we're trying to grab some.
The labs
Yeah.
for, I mean, I could, but the robot that they use is a custom robot, so you would need the.
Well, I don't want to use it exactly. I'm just kind of curious on the, like, I like to, yeah, I do like.
Yes, do you have something right? Or?
I can email you.
Sure. Ben, Ben, Partida, PARTIDA, at CSULB.edu.
We can target it with you can use a servo to like aim it.
Maybe.
Thank you. Sorry, I don't want to take your lunch.
It's okay. And maybe you can come back next month. And
Yeah.
look at the-
Anyway,
Yeah,
they're about,
curious if
I
you
think
know
they get
the-
about $22. About,
We extended the deadline, so you have time.
Okay.
I guess they probably want to
Is there a deadline to like
to work.
Hopefully they won't have ran out.
No, I mean, it's, I can afford dollars, but I don't.
I can make something. I'm gonna turn it into a project for a class.
Sure. Even if you don't complete it, you know, just bring whatever you have. We always like to see what people are doing. Yeah.
Just
Thank you. Nice meeting you.
Nice meeting you too. Bye. Les, can you hear us?
Oh, he left.
Les, he has some comments for you. I see him in the chat.
Oh,
Oh,
I better check that.
Let me see. Did he?
comment here on the batteries, I believe.
Oh yeah, he left.
I think you can also see the comments directly on your computer.
Yeah,
Oh, well, I'll take a look.
yeah. He even sent you some links.
Oh, that's good. I'll take a look.
Well, oh yeah, he sent a link for a 300 amp 12 volt battery. Do you want to do a short sale, Jim?
Sensors. I might want to use like a select shape sensor.
Oh,
I don't know how to interface it, but it came with some things to find it. But
so, usually, let me look it up. They usually have documentation for it and usually tutorials on how to use it. Where did you say you get it?
On the website is DF Robot, Syncing Robot. It's all the word.
Yeah.
It's supposed to be infrared and it's time of flight. It's measuring, but it's got
Just go there. See you.
8 rows and 8 columns of beams. So you get 64 range numbers. They advertised it as being like morning grid something, but that's going to be a huge amount of data. I don't really want that much data.
I'm pretty sure you can probably
Hopefully it doesn't
filter out.
it down.
Which one is that? Which one is?
It's shaped like it's got an extra box on it there.
Let's see. Let's see. Hey, search what is it called?
It becomes the 8x8 time TOF. Oh, oh, oh. Oh, yeah, that's awesome.
SEN 06. Oh,
That's it.
oh yeah. Microbit. That's strange. ESP32 Raspberry Pi, you have to have
At least ESP32 is good.
Yeah.
Okay, but I mean, what yet?
They're little and for what they do, they're pretty good.
Both are cheaper than already. A lot of the clubs on campus try to shift to ESPs and SDMs.
I was hoping you would have something like a building test or something so I can just find out whether the darn thing even works before I start spending a lot of time writing code for it. When I was designing like at Lockheed, everything had to have built-in test. It was all for the military.
Product wiki.
Maybe the project's resource.
The trick there is to design so you only have to add just 1 or 2 electrical parts. So then the whole thing becomes completely testable.
Setup. It's not a sample.
So here's a a project that uses it
Oh,
right from their site.
I see.
Has the hardware list. It's using Arduino, how to connect it.
That's useful, yeah.
Here's all the pins.
So that's using the ESP32. The parts list,
So-
it showed ESP32 and then it said like dash something. Dash, what is that, C5 or
Where?
there? Oh, that's something else.
Yeah, that's the whole, I
So
guess,
is there
model
more
number.
than one kind of ESP32?
Probably, yes.
Right.
So you might want to like go back to the main one.
Yeah,
Uh,
see, that could be a really cool sensor because it goes out quite a distance.
and at the bottom
it's
of
very
the,
short range cost.
at the bottom, or kind of towards the bottom of that product page,
Yeah.
there's under documentation,
Mhm.
there's a wiki, and then projects, and
There's
there's
that
this
project.
guy, which the project is the one that has all the hardware and everything for the project that they're showing.
Mhm.
Wiring, the pins, and then I think these are. Oh, there's even a GitHub for it where you can download the code for it.
Yeah, that
Here's the
would be
link to it.
That's usually a good way to start because later if it works, the sensor works, you can start modifying the code to make it do what you want.
Yeah, it looks like it's very well documented. Pictures and.
You know, these things were like only about $22.
Different, it's all very well documented, different steps.
Mm.
Processing. Yeah, you might want to check out
I'm gonna do
this.
this. I mean, you showed me how to do that. You know.
And then on the wiki, it probably shows all the specs for it.
I think I could fit this inside of a kit smaller.
Download resources. Oh, here's the GitHub for it. Specs. Oh, here's the more projects. Oh, it's the same one. Here's the specs for it, documentation. Oh, here's the getting started.
So the guy,
Example
under the,
code.
under the specs, does it have like a minimum range or a maximum?
To it.
What are the tech specs?
Oh, yeah, it's very well documented, Jim. Here under, if you click on this little link here,
Yeah, yeah.
it takes you to this guy,
Oh,
which has the full specs of it.
I see. It looks like it works with multiple addresses.
Oh yeah, here's the array matrix that it gives you back, and probably a way to.
See, that's gonna be the tricky part. Once I have the matrix with all those distances, I gotta figure out the solid shape of something in 3D and pre-plan the graphs. That's gonna be the trick.
It's an 8x8 matrix.
Yeah, and it's measuring all those distances. So that's the next thing I'm gonna do for this project.
So look here on the side.
Yeah.
It has getting started, example code for Arduino obtaining 4x4 matrix data. Example code for Arduino. This is obtained. This is read 4x4 matrix. 8x8 obtain and read. Example code for Arduino.
You know, I'd like your professional opinion. If all I'm trying to do is get a rough idea of a three-dimensional shape with a 4x4.
Probably does give you a better, a rough. And,
Yeah.
and if you want more detail, go for the 8x8.
Yeah.
You could probably just get away with the 4x4
For some things.
for most of it, because I mean, unless you're like really trying to, get really high resolution of what it is, I would say probably the 4x4 is good enough. Yeah, there's a whole bunch of examples here.
Yeah, because
This is what you
my-
need.
My overall plan, objective is that the robot should be capable of grasping and picking up anything that you can pick up with one hand that you might find in your house. That's a huge variety of shapes.
So look at these examples. So it shows you the read and obtain for different ones, and then it has how to get specific points.
Oh, that
See?
could be very useful, yeah.
Obtain specific points, data via York, I square C. So yeah, it's a lot of examples here.
Correct.
This is in under the getting started.
I'm not considering getting started.
And of course, this is all under the, I believe that was the wiki. Yeah, this one.
What's
the product wiki?
Cool. It's on the wiki.
Yeah, and the whole thing is under the product page for it. If you just scroll down, you'll find specifications. There's the document, the product wiki also has the project in it.
You know, when I make more progress on this, I might want to do a show and tell.
Yeah.
When I get it to work. I don't want to do this in advance, but when I have it working.
Here's some code samples.
Because other people might want to use something.
Yeah.
I think this is more than a one weekend project, but but you can see where I'm coming from.
Yeah, this project that they did is detecting a blink.
Oh, that's what they're
Yeah. Even tracking of a blink.
Yeah. Well, thanks for that.
That looks like fun, Jim.
It's being tired.
Yeah.
Cool.
What's up, MJ? How you been?
No,
You want to use my robot for the next part of the?
Oh, yeah. I'm just going to explain that.
Do you have an arm set with it?
Not the arm, but you can use the exact same lifting mechanism because it doesn't have to be a can.
For me, it's
The actual can is just a little square that's still out to take. You just gotta put it into that. Then you gotta go around the can, pick it up a little bit.
Is it also, I don't know if the dual side one, does it require like color sensors also?
I do. But depending on, you might wanna, it has a line sensor, the rotary has a line sensor in which you can detect the lines. The only thing that we gotta figure out is how far it's gone, so the odometry. Because if you start, like, say, if you start the robot at the trash can, you gotta figure out how far you went to get a can, so you know how far back to come back to drop it. It's very.
I'll see if I can find any commentary.
You could, but it's definitely an option.
Looks like it's working. Chat.
We'll get it set.
You're welcome to use the robot if you wanna. You wanna try it?
I'm debating on it. I want to try to see if I can get my friends in on it, but
Go for it.
it might be a little burnt out on projects.
But you guys are in the summer. This is one season time.
Well,
What is this?
Or are you guys working? Are you working?
no, I haven't lined up.
Yeah, it's,
My friends have. So. Only thing I'm not working on is a battle bot. Or another battle bot.
Or the Maker
Or
is that different?
Yeah, so for the Maker Faire, we should be building 2 robots. And this new robot has been in the works for a year now. And I'm really hoping it goes through because it's had
a lot of setbacks. And that
I'm
one is a little more
eavesdropping. Are you guys talking about BattleBots?
Kyle, part of that?
No. Kyle, Kyle does. Kyle is actually working in his summer, but he'll also, I think, burn out. He was at the ASME for.
Like he was doing a lot.
He was doing this all at the same time as taking your class, right?
Yeah.
He had a senior project too.
Yeah. He didn't graduate this last month, did he? Or did he say he had another semester going?
Yeah, I don't. I know he's. Yes, I think he's eligible to receive a proposal, but like, I don't know if he like filed for it or not.
Because I know he told me that he got accepted to the master's program.
Oh, oh yeah.
But I'm not sure if he's starting that in the fall or does he still have another semester?
Oh, I'm not sure. He's talked to me about the masters a bunch, but I didn't get an exact update on it. A lot of the seems like a batch of people because I know like I don't know how many people from ET are graduating exactly, but it feels like I know of at least like 10 people graduating from ET, and that's like a sizable portion of the major already.
How much more do you have to go?
2 more semesters. Well, my last semester is going to be like 1 class and a half.
Wow.
I still need to get my field work in, but a lot of people graduating were working for like I don't remember the names of their professors. Or one of them working for Leo when he's graduating now. One of them was working for Sir Anne at her lab.
Yeah, we're moving on that. So you need it.
Yeah, and the thing is, I think those only open up during. They only like formally open it up during like the semester. So
Yeah.
I'm like brushing up my resume and like trying to pull the trigger on that as soon as possible.
You look for student assistant positions in central IT or just the department, the ones that work for Leo.
Yeah, yeah, because I know a bunch of the people graduated, so
There you go. Just looking for new ones.
yeah.
Yeah, go talk to Leo. He's pretty cool.
Asked asked one of my friends to reach out to RSSC graduated, but is he still on campus?
Who? Who?
Leo?
Oh,
Oh yeah, wait, you guys technically don't get summers off, huh?
right inside of your.
Oh, you work for you do like the IT stuff here, right? How was it during the big like incident back in your finals?
With Candace? I mean, from our side, it was just an inconvenience for the teaching side, but it was all Candace side. We didn't have anything to do with it.
Oh, okay.
Yeah.
It was actually a little wild because I was actually in the Horn Center when it started. I was in the Horn Center and I went up to the technology help desk there, and then they're like, you know why Canvas has gone down? And I'm just like, oh, it's a scheduled maintenance. Don't worry about it. It'll be back up soon. And then I think all of them started gathering around. No, it's funny because like all of the help desk people like gathered around to like talk about it. And I was just standing there and just like nobody knew what was happening.
Mhm.
I was studying for I just needed access to my materials. But maybe I might try to use your robotic and if you don't maybe I can rig up an odometry wheel. Sort of put it on the side and then reset it during. Ooh,
I mean, we can add a odometry to, two of the wheels, so one on one side, so that you know, like, how much it turns. Because one wheel by itself probably will work, it just to give you how far of a distance in one direction.
yeah.
But if you have one on one side and one on the other, you can actually tell, where you turned and how much you've gone after that.
Oh, okay. I just didn't know if you had the pins left over for that.
Ah,
At least with one odometry wheel, you can at least measure the straight line distance.
yeah.
And since it's separate from the wheels, you could track the angle you turn by converting it back from distance.
That's pretty much going back to, uh, uh, just using, how much time you went going backwards.
In the last second, bottoms real last. I really want to make an bottoms battle. But there's something about brushless motors that really messes with the circuitry.
Not really. I mean, as long as you use the motor driver, just wait for it.
Okay, maybe it's probably more on me and my team then, because we're trying to use it with a radio receivers and a radio receiver, Arduino, and we're just not able to get the. Every time we try to interpose an Arduino between the receiver and the motor drivers, there's always something wrong with like the outputs.
You can always just keep them separate. Drive the remote control part just as a remote control part, and the sensing separate.
Yeah.
Or I don't know, like what you guys are doing with the sensor with their ring.
I believe the bare minimum was using it to like detect the electrical usage inside the robot and act as like a little bit of a damage detection system. But I'm the only electrical person on the team, so the troubleshooting and the theory is like really sparse. When was the last time that the clean your room challenge was done?
I think it was pre-COVID.
Oh my goodness. I wasn't in college then. It's kind of funny to see during Jim's presentation the allusion to like, oh yes, you remember the paper from 1995. I was reviewing the live.
Yeah, the club goes back to, what was it, mid-80s, 80s, early 80s.
I heard they met at Orange Coast College.
Yeah. I
The
think
first
it was,
meeting I went to was at Orange Coast College. It's right across the street from the Orange County Fairgrounds.
wow. So I mean, I wasn't around back in those early days, but, from the documentation, it seems like it's been like maybe late 70s initially, and then it kind of became what it is now in the 80s.
Yeah, I found it online in 2004. Or something.
Yeah. I saw some of the articles. Remember, there used to be an actual like paper uh article that we used to publish with tutorials and all kinds of code bases and instructions for stuff. Like a literal like a paper. Remember the paper newsletter we used to send out?
The Orange County,
Huh?
the Orange County Astronomers had a newsletter.
Well, we had one. We have one like an actual paper one. They used to get it mailed out.
Yeah, it's called the Robot Builder.
Yeah,
A lot of my projects were published in Robot.
yeah. That's ooh. And those go back to many years. I mean, oof. We have a lot of them on the website.
Right, you had articles, yeah.
Oh, yeah. Yeah, sure. We've been around a long time.
Yeah. Probably one of the longest running robotics clubs in the nation. Wow.
I had to pay more. It was money.
It was the same. Was it over $10, Jim?
Hmm?
The
$10
membership?
paid for a newsletter.
Darn, I forgot to pay that. I better go out there and pay that.
But back in the day, was it still $10?
For what?
The membership fee?
Oh, I thought you meant the parking.
No,
I
no.
forgot to pay the parking.
Oh,
I better go do that.
now for the membership fee back in the day,
It wasn't much.
it was less than 10.
I don't remember anymore. It's too long.
I think it wasn't. It wasn't. I don't think it was more than 10. The burning.
No, that was like for a whole year.
Yeah. Still is.
Oh, we don't have to take the room.
Who is collecting that, by the way? I don't know if I'm up to date.
So Alan is the new treasurer.
Oh.
Yeah. Ron retired from treasurer, and now is Alan. So you can talk to Alan in person or through the website. There's also a link for
Oh, okay,
to
sure.
PayPal.
Mhm. Yeah. In a few minutes, I'm gonna go out to the parking lot and pay for that to do that. Look at this robot pocket. Look at the cute little robot.
Oh yeah, Dennis. He showed me that. I think he brought it to the Nature Fair, LA. He had him with him. It's a pretty cool project. It looks like maybe some module. He's gonna do a show and tell with it. A little bit.
Ah, then I'll find out then.
don't think I understand what a subsumption architecture is still.
Oh, well,
But I'm looking at the Wikipedia for it.
each little module just has like timeout. Yeah, it's like that. But each little module of it has some triggering criteria. And then there's like a time, there's a timer that starts up, so let's just do something for a certain period of time. But each one, the way the arrows connect, coming out there, this one will preempt this one. This one will preempt this one. So you code this layer first until it really does avoid objects. You don't code all this stuff at once. And when you get that to work reliably, then you never touch that software again and code the next level up, which can preempt this. So that this thing will compute how the actuator should move. But it gets overcome by this one, which takes over. But when this guy has no reason to wander around, then it avoids obstacles. And so on. So you build it one layer at a time. And the trick is to make sure that you get one layer working reliably before you start working with the next layer. Then you have to go back to the original code and change it.
Okay, that makes sense.
But instead of having like the way I showed, where there would be a separate module of software that's a hierarchical planner that like decomposes it into a bunch of subtasks, I would just do something like this.
Oh, okay.
And just write one of these separately for each kind of thing it can do. Maybe, I'm not sure, but would be the best way.
I don't think any of my robotics projects have gotten complex enough for an action planner. I think most of my robotics projects are more like actually closer to this.
Well, you know, for like the robots that I have for contests, I've been using the subsumption architecture. It seems to work reasonably well. But I don't know about the complicated robot that I was describing in my presentation. So maybe it can, I think. Did you understand when the other fellow said the name of the robot I was referring to was Baxter?
I wrote them down. So you mentioned Baxter, Attila, and MIT.
Could you look at Baxter? Robot named Baxter. That's it.
I read the
It
robot.
was made to like vault to the floor. No. And you could train it.
Like, as in you
can train it to work, do tasks in a back. Like pack things accurately in boxes or on a production line, assembling things. And that used entirely is the subsumption architecture. Pretty sure it did.
does it you move it, so you physically move it at the location and it remembers
It
that.
has sensors that then knows if you grabbed it.
Oh no.
And then you move it around to train it so that it knows what to do.
Makes sense. I guess
Like there's a push button on the hand that tells it, okay, grab something, but then it figures out by itself how to grab that thing. Those things have different shapes.
usually nowadays you can say you can train the robot. We're talking about the like neural network. The other one was still might be. Oh man. The media for it is like Flash.
Sorry, what did you say?
The media for Hannibal and Attila from MIT
Oh.
are like are written in like the Flash web format, which have been like deprecated since. Does anyone know when Flash went extinct?
Oh, yeah.
What year was that? Like,
Wow, back. That was my, I guess, the thing that I used a lot, Flash.
there's a lot of good games in the Flash format.
Another cool sensor here. You know, the one that I passed around, which is flux sensor that detects resistively flux. I have another one that was here. Let's see what this one does. The other one had it on here. This one is fantastic.
I was going to show you the, we're asking you about the two videos.
It detects like anything, vibrates and moves.
So, and I see a way to get to it.
Like voltage.
This, if I can go to our
So,
website, it's the RSSC.
authority that and a little thing, they begin
So
what's the drive like logic? So they probably don't even
scroll all the way down to the bottom.
Oh wow. It works by like the plates move distance.
Well, you know, it's like the difference between like an electromagnet from a permanent. So
We're at the
a permanent magnet is always a magnet.
one page of our website.
It's only a magnet. Well, we have are by
Here in the corner, YouTube,
an electromagnet.
click that.
Right.
It takes you straight to like our YouTube channels.
Electric field.
Now look at that handsome guy there.
Yeah.
And so,
And from here, it has all of our videos. So by default, it usually goes like a for you and then other little sections. But if you just go straight to the videos,
I took one of these and I sandwiched
it
it
has all of
like between like foam rubber and something else.
Alan is the one that uploads these, so he sometimes maybe a month behind. But all of our videos are here.
So I thought of this interface circuit here.
From here, you can
watch. And so one of those things I just showed you, it's in here. Like
They're all
between this thing, these wires that go in here, it's sandwiched in here between like this foam rubber. And this is Velcro.
Yeah.
It's all little things. So like, here's another example of a slip sensor. It was
Yeah, probably might have been
an object grasp was like slipping.
for you. And
These things little times one at a time.
Yeah, well,
And then these clicks comes out of the voltage in here. Flashes the light. These guys can burn. Can I bring the battery for it?
Yes. So you are on a small page. Included it. Our website.
You know, I'd like to start to see that work.
And well, all the way down to the bottom.
That's
It has a little bar where so I did get that far. And just when the YouTube one here, click that one, feel it push, and it jumps straight to YouTube and right at our challenge, YouTube channel. You know you're at the right place, you can see yourself there, right up front. And from here, you just click on videos. There's all the recordings for all of our videos, and as you can see, they're all usually 3 hours long. They have the little timestamps, watching the bonus. Oh yeah. 2 hours 43 minutes, 3 hours 90, 3 hours 5.
Something in the hand, this pipe. Here you try it.
And then from here, you can select the other one. And,
That little dome thing that I showed you is built in that sandwich in between. I think I basically done by this website.
no, I just put off on the grass.
Is this the frequency of the time responding? You artificially find so here.
So that makes me like more variety maybe.
But I'm not using it. This is now.
so
you know, you need remember from our website, so go all the way down to the bottom. Look for YouTube button. Yeah, you can search it.
And this thing here,
all the other one out there, basically.
So if it was directly with the group, you would actually.
Yeah, because there's a good point.
Yeah, but I'm hot right now. So
Very
sensitive. I've had 3 minutes.
Who said on the resume?
Yeah, and so it seems YouTube button a lot more mechanically so.
Yeah, it was before the other one.
Huh?
Well, it would work. So. Now I have two dollars.
Trigger, this one here.
Yeah, well, see, it's not being booked. So the light doesn't like this.
Mechanical.
I guess. Does it get by six?
Yeah, I think it knows material.
I have like false positives, if you know, like some people think are low, so like happen and
I'm impressed with the stuff that can make that sound.
Yeah, I was gonna say like awesome.
You do, like, internship kind of thing?
No, it was full-time.
Oh, someday, not today.
But it's getting.
Here's what I do. It's a horrible idea. My mind is a horrible idea.
I think they're so hard.
It's a jump start.
You get this.
I mean, you need to find your back there. You hook it up to a dead bat.
It's called measure.
Nothing, it's just straight.
It's
Yeah.
No.
You're basically shorting your
You probably want to go in certain directions.
The rest of it, I think I'm not gonna say it's gonna help it, but anyway, I'll buy this. Cut those,
And you're ready, it's not anything stupid.
yeah, I'm not gonna buy the.
Yes, you are.
You can do it because a lot of marketing and all that, see all the things. But now they get older, of course, you want to have more stability and have.
The most better from the words.
But anyway, I think
Yeah.
I'd like to make a statement to full-time job. They can help some friends of mine, they went to places that only have. I would have to use, they got to do a lot of different things.
I mean,
Yeah, I'm trying to find small.
it's really do a lot of different things. You already had it. Yeah.
Yeah.
I don't have kind of.
Yeah.
It doesn't make.
Some stuff he does. I still like that he's like actually testing it, he's methodical about it. Yeah, I didn't always agree with whatever his methods and how he judges something good or bad, but I like that he's testing it.
That's an interesting point.
Yeah.
Like a test channel.
Oh, yeah.
we're late.
I think it's not a short. Perfect. I watched 2 hours. Is anything else there about it? Like, are the gear races go out at 500 pounds or at 800 pounds? I don't care.
I got a lot of.
Right.
Oh,
yeah.
Right. Everybody,
How do you guys?
Good to see you.
Oh, just say, yeah. First, like 500 pounds.
So then I go, well, then that's good first.
Hey, Ron, good to see you, buddy.
through a serial.
Like the.
And then the yacht.
Big bowls, but.
Every day I find out. In one robot. Oh, there's also. We got prizes.
Might be rusty, but everybody.
Oh, hey, Tom, it's real.
That's pretty, yeah. I mean, that.
Guys want that? Another donation. You guys want cameras?
Or shop.
Sure.
You got.
Oh, right.
Got leftovers from your life.
Yeah, I'm still digging out the stuff in my garage.
Hold the doors.
Whatever.
So you don't bring your own fire.
All right, everybody. Anybody want buttons? Let's sit down and continue our meeting. Okay, so as we discussed this morning, we wanted to really take another vote on moving the next month's contest over to possibly November.
I
Because
think that's a good idea because I've got a video about with me test out in the hallway, but all I'm testing is the line sense.
yeah,
I don't
so
have the rest of the software with.
You're ahead of everybody else.
It's 2 months.
yeah, we proposed November
Okay,
for the new date.
that
And
sounds
that
good.
could be kind of like the end of the year contest.
Yeah.
Okay. So since Jim was the architect of this contest, and he approves, I think we can
Oh, go for November?
put it on the books for November.
Okay.
Okay?
All right, and as part of that, starting this month, we will bring the tape for anyone who wants to throw out in the hallway during break or show and tell to practice if that's necessary. I'll look at the rules and then I'll bring something in so we can set it up for anyone who wants to try out the contest.
I'm just using a roll of ordinary black electrical tape, like hardware store.
Okay, like,
It worked on the linoleum floor in my kitchen, but I'm gonna test it later in that hallway to be sure.
Yeah, being that that's gray floor, I also have some white electrical tape we can put on against that black tape if someone needs that as a
Now,
contrast.
there's an idea, yeah. It will show definite contrast.
Yeah.
I didn't know you could get white electrical tape.
guys, I
Yeah,
know,
I have a long
board.
time.
Remember the board from the other club? Do
Oh,
you want that? You can bring it next month. How big is it? About 6 foot by 3.5. Okay, I think our contest area is 6 by 6, right?
That's the.
Oh, that won't work then.
But I mean, we can always just use tape. We don't need liquor.
Yeah, tape on the ground.
You don't want the board then? I'm trying to give it away. I'm trying to empty my garage. I got a lot of that stuff in my garage.
a lot of cheering here.
All right, so the contest is for November. Thanks. And we also wanted to kind of take another poll and see who is willing to come and man the booth at the Orange County Maker Fair. If we go, it's a 2-day. It's on September, and one of the days lands on our meeting day. So it kind of puts a cramp in it. We either not have the meeting and just live stream a little bit from over there, or kind of skip it because they kind of want have us for the entire 2 days. They kind of want just being there one day, especially if we're not there at the opening day. So Who would want to still go?
Yeah, I love the idea. The only thing that makes me nervous is trying to manage an in-person meeting and I want to attend both days, so you'd be shorthanded here. Maybe like we did in our previous year, we just get the club meeting.
I mean, I'm okay with that. We've done it before.
Oh, for the whole, yeah.
And if we do that, to make it lighter for us so that, if you can't commit to both days, we can have a list of people that can do Saturday and then a group of people that can do Sunday. So our booth is manned both days. We can definitely do that.
Do they have a minimum time you have? Do they want you like at 7 to 3 or some numbers like that? Yeah.
Yeah.
It's usually not that early, is it?
Well, I don't know. I'm just throwing up.
But they usually do open a door somewhere around 7, but
Yeah.
I don't think it starts until like 10.
Right,
Oh,
I think you gotta get there by 9, it's like the
Oh, okay.
Yeah, that's how it usually is. So
Is it indoors? 'Cause I remember the San Diego one was there 2 days and we just left our stuff on the
yeah,
table.
so the way that Orange County does it is that you have the option of being indoors or outdoors. But for us, we're always indoors, and then they also give us the option that if we want to fight. Because one year we were right next to guys had a booth where they were drilling. They had a
urban workshop.
these all going on.
It was funny, there's the whole workshop.
And it was really hard to hear people.
Big, big, woodworking sawing.
We were next to
Yeah, we need to try quiet for voice recognition type of robot stuff and also the visuals so your screen, you can see a screen.
It's
It'll be quiet though.
It's not quiet. It won't be quiet because there's just so many people there.
No, it's
a lot of
definitely not quiet.
kids yelling but at least it's quieter than being next to like the wood shop guys. So that's how it was last year. We had our booth that was somewhere in an isolated area.
Ours was pretty good, like quietness wise, it was okay.
Because we asked for that.
Yeah.
So
we
we
were
can do the
much
same.
better than the previous.
Yeah, we can do the same, but again, we need to be able to man the booth at least both days.
That'll be September 12th and 13th. Then, huh?
Yeah. So
It's also a matter of like, whether you're going to be satisfied engaging the crowd or not, because like and how much work you have to do as a presenter.
It is a lot of.
Because I remember last time, like, do I really want to do that again? It was like, did I get the satisfaction, or do I need to restructure the interactivity of my presentation? Like, some of our members have much more interactive things that the audience can interact with, versus the robot that you're controlling, this advanced thing you've designed, and then it doesn't even recognize their voice very well or something.
yeah, but if we go be prepared to be there the entire time, which is usually like somewhere load in is probably
It's a full day,
maybe 8, and then
8 till 5.
somewhere around 5, both days.
Well, we only need to do one day. I mean, if we balance it. Right?
Yeah, I'll be there.
yeah.
I'll be there both days. I'll make that party.
I'll be there both days. And then you guys can decide what day you guys want to be there. We just need to have enough to, have enough robots for at least one booth.
They provide the tables and chairs.
Yeah. It's like it's like 2 chairs per table maybe.
And power strips. Those.
Yeah, and we order the power. You have to bring all your own power cord strips.
Yeah.
And cable and extension cords. They'll provide a single drop, and the thing is that basically we need to decide before by the deadline of the application if we're going. So if we have enough minimum attendance.
Yeah.
So the deadline is probably coming up. It's in September. It's probably 2 months before that is the deadline.
Probably next
July or
next month.
So we probably
Let's
need to know.
finalize it by next month. Okay, so just think about it. if you guys, wanna, attend, let us know, so we can submit the form.
I was thinking that at night, one time I did a similar thing where you have robots there, but for the little kids that are like kindergarten through fifth grade, you have a little tabletop thing that they can learn electronics or whatever, and I put up a set of things, like what does potentiometer do, or, how do you make things bright or loud or whatever, things like that. I did timers, so we could do something like that. But I mean, of something the kids can actually learn something rather than just observing, but they actually do something with their hands,
Carl usually brings,
Carl
it's,
Did you say Thurman?
friendly displays.
Did you say Thurman?
Yeah, yes,
Sound
the
machine.
marble name, allows the sand
Right.
So, yeah, Carl usually.
Table. What do you-
attracts
yeah.
a lot of people, maybe the kids, because they all want to take a turn of.
Actually, yeah, Carl's got that kind of covered for our booth, right? And so, but
If he wants to be there both
if
days.
he's gonna be there, yeah. We haven't talked to him, or haven't committed,
I think last year Jim brought in his marble computer, and that was pretty popular.
It was popular. Yeah, a lot of people wanted to see that.
That's where I missed that. That was the second day you were there.
I have a theremin. I can bring a theremin.
I was just mentioning.
Anybody wants to see.
That's like electronics. And
So do you want to, will you be willing to attend this year as well?
I probably will.
Same place, Orange County.
Oh, okay, I know where that is. Yeah, yeah. I'll probably be there. I don't, but I need to know ahead of time if you want which of those you want, like
Both.
both? Maybe both.
Bring everything.
And get your car.
Yeah.
Yeah, I guess I could bring both, whatever.
Well, like I said again, my BattleBots team will be there both days competing. Our bots aren't safe to demo outside of the arenas. They may be broken during large portions of the day, but it is a set of extra hands of people that are willing to, I guess, man an exhibit or go to one of these.
Or even volunteering to man our food.
I'll see how much they're interested in, but yeah, so some of them seem pretty receptive to it.
Sure. We'll take all the help that we can get.
So some of those, like when we did San Diego one year, we had a really popular booth, and we were next or very near one that had all these little things they're giving away to kids. And so we had a stream of kids passing by our area, and they all went home with whatever gummy worm thing or whatever it was. And then when they came by our booth, and we were busy the whole time.
Yeah.
Yeah. And then Sergey, I think, had the one robot that would shoot darts at you.
That's right. Yeah, I went to San Diego. I went back to San Diego. Even beyond that, back to Irvine.
Yeah.
When I first joined.
Oh, what's the ground like? Is it paved? I mean, is it cement ground?
It's perfectly, kind of like the hallway here,
Oh, good. Okay.
very smooth. It's fine.
Yeah.
Hey, I have a Robo Scout. It just makes a lot of noise. It makes it a lot of, about this big. I bought it from the Dr. Bruce a few years ago. Do you guys want it? I'm trying to lighten up my robot stuff.
I think my wife will kick me out if I put more stuff in it.
I think that goes for most of the.
I don't have a wife.
Does anybody-
You got rules.
I think he's saying he wants it.
That was an implied yes.
Right, because your buddy's Robo Scout based, right?
Yeah. So that's spare parts for me, kind of.
Do you want mine? Do you want?
Well, the thing is, I'm running out of room the same way as everybody else. I got a room just dedicated to robots.
One robot in, one robot out.
All right, so it's a yes on the Maker Faire?
As of now, yeah, we.
All right, tentatively, yes.
Because we kind of want to check with Carl and see if we have critical, we have to decide like, what is the critical number we need? We certainly have both, if you only have two of you, or if there's only two people committed to both days, then we need more than that on each day, right?
So I think we usually get 2 booths, right?
2 tables, I mean.
2 tables? It's just 1 booth?
Yeah, it's one
Because
booth.
at the LA, we had two.
We had
Oh.
2 booths, 4 tables.
Oh, 2 booths, but this is, indoors, it's not, there's like, it's tables, it's one area. I wouldn't call that a
But it
booth.
was the length of two, right?
Yeah, two tables long. That's still considered one, I mean, it's one booth because it's Robot Society or whatever, it's RSSC booth.
And we need to get some, good use out of our new banners that we paid for.
Oh,
Is the booth set up such that kids come into the booth, or do you have it a table as a barrier?
No, the table's a barrier unless you.
Although.
You could make a U thing if you really
Yeah.
push them. And you get 1, 2, 3 tables at least, or 1, 2, 3.
We've done that before,
Yeah, the U shaped.
a long time ago.
Yeah,
So,
we did it at the Orange County one, in fact. Remember when Trish was there and? Yeah, so it's possible. We'll have to make special requests, to make it even bigger then, but normally if you only have, just like last year, it was just tables in a row and they come up to the table and the table's a barrier. But what I did is put stuff out in front of the table on the floor, even though people might walk up, like I had a map of a robot or like a map on the floor where the robot could move around and people might step on that. But if you kind of outline it, you can try to keep people from stepping on it. But you can have that out front.
Is it a situation where you have too many people walking through and you can't have your robot out in the middle of the floor area? Because they'll trip over it? Is that much traffic?
Yeah, as long as so that requires, like, I am always out in front. If my robot is out in front of the table, I'm out there protecting it. I'm not behind the table unless it's off and stowed. So yeah, you need to, if you want to move your robot around. And some of the groups had races of little robots, and the attendants, the people that ran the booth were, out there with those.
Yeah.
So
And people usually come in waves, so, you have one little wave of, maybe a bunch of little kids or a bunch of adults, and then you'll have a little downtime and then another wave.
I recommend, like, I printed out this huge map for that robot that I bought, and it had this, it had a course, and people can see this big map on the floor, and they won't necessarily just walk into it because that looks like a race or something.
Yeah.
So if there's something you put on the floor that's different color, then or it looks like a robot arena,
Right.
then that helps.
So do we want to request more than one booth, or is that?
Depending on how many people.
Yeah, we would at least, usually we get two
At least 2 tables, one booth with 2 tables. But, like at the LA one, we had 2 booths, 4 tables, which was, it was nice.
We ended up filling it because you had your engineering stuff and then you shared
Yeah.
with Carl who had his 2 things. That was 2
Two
tables,
tables.
I think? Yeah. And
By booth, you mean it had a canopy or something? Is that how do you designate 2 booths versus
Well,
one?
all of them are different booths. I think, I don't know, like they're probably like 2 tables long.
Yeah.
And that's one booth. And then we had 2 for LA, which was probably about the size from here to the wall.
Oh, so it was pretty. Yeah, I remember seeing the pictures, but
Yeah.
at Orange County, we generally just get one booth, and so it's all together.
Tables long.
anyways, yeah, we'll dig
Tables
into it when we apply and we'll see what's available. And
Yeah, we should figure out what we want as far as
How much table space each person might need? For
Yeah,
that.
because it gets used up pretty quick if people because each table is usually 6 feet, and if you need 3 feet per person at least, then you figure that 2 people per table.
Ethan is pretty cool. I'm pretty sure he'll give us whatever we
I mean,
need.
I would love to do like a 4 booth corner like we did in LA.
Oh, yeah.
But I don't know if we have the manpower to keep that up. For
You mean
2
what you
days.
guys had this past?
No,
Ethan.
Ethan had 4 booths with 4 tables.
Oh,
so there's
he-
plenty of room to walk around.
Is one, yeah.
Yeah.
Yeah, you said the 4 top or
Yeah,
something.
the 4 top. But I don't know if we have enough. people.
That's for a bigger organization.
Yeah,
And it takes manpower.
yeah, and the available space. We don't even know how
Yeah.
popular like
If it's indoors, that means space is limited. So.
It is, yeah, it's mostly indoors. I mean, that's where we generally want to be because of the nice hard floor.
The hot sun.
Yeah, and the sun.
Air conditioned inside.
And you know, your robot wants to, you know, our robots are floor robots mostly, or it's human.
I wouldn't want to be outside.
No.
We did that, what was it, the LA Maker Fair back in like 3 years ago, was it?
Yeah, I was there.
We were out on the park.
When I was there, where the,
Oh.
yeah, where the parking was terrible.
Terrible parking.
And then we wheeled our stuff into the grass. You know, our booth was on grass. But the LA Maker Fair this year and last year, we requested hardwood floor, and of course, I didn't make it this year.
Yeah,
and
it was nice.
the hardwood floor is great for the robot.
Yeah. Everything was great except for
The loadout.
the loadout.
The load, yeah, that's been their Achilles heel.
Okay. All right.
Yeah,
So
tentatively say yes. Now we're getting excited about it.
Right. So, should we get started with the show and tells?
Let's do it.
And Jim, you're up first.
All right. So share my screen. So I'm gonna talk about Big Orange underwent a few months of work, hardware for now what I'm calling version 6. So this is what well I've already disassembled the top level here, but this is was the older configuration had this sort of just claw that I happened to have, and I wanted to go through an effort to at least get the robot to pick up a bottle and using a sonar and using the navigation, find the bottle and all that. And there's videos of that in my YouTube collection. But this was just a sort of experiment. It's not, you know, not terribly useful or but just a decent demo. What I needed to do though overall is to rewire to increase the power availability in Big Orange. The main reason I took it apart was just out of power. I'm powering multiple computers. I added a new Jetson Nano for the AI computation. It was on a separate battery. Even the Latte Panda main computer, which is not pictured here, here's the other half on the table. That was upgraded to the Latte Panda 3 Delta, which eats more power. It's double the speed in CPU and multiple times in GPU. So power, and then the Oak D camera, I have 2 of those, normally just 1, but this thing eats up a lot of power, and I want to use it a lot because that's the vision, and I'm sending that vision not only in the camera itself to do 3D spatial disparity, depth recognition or depth, sort of computation of objects, but I also send the images down to the Jetson Nano now for more advanced recognition and all that. And so it eats up more power. So it was, and a battery was going dead. A single battery was being used for the entire thing, motors, electronics, everything. It was getting drained too fast. So I went to a 2-battery system. But at the same time, once I had it up, so I did all that electrical work. At the same time, I realized, I've wanted to put an arm onto our Big Orange for a long time, and a lot of people with fairly advanced floor robots get some kind of 5 or 6 degree of freedom arm attached. So I had this Yaboom Doffbot that was driven by the old Jetson Nano 4 gigabyte from a few years ago, and it came with this plate. So I said, all right, it's time. Since I have the system down, I'm gonna get this arm mounted. So, and now here you can see this, I had two of these batteries. I bought a second one. So I decided, all right, it's time. These are the two battery packs, each is 12 volt, 6 amp limit on each. So now I have 142 watt hours. And you know, I just, with two batteries and then redistributing all the power to the different devices, I'll have much more time and much more, you know, ability to handle all this stuff. So here's this plate. I drilled some new holes in it, and it nicely fit. I mean, this is a coincidence, but just had to shave off a little of this bumper and these bumpers, and this thing fit right in that space. So
Meant to be.
yeah, and it's black too. So, and then here, so here, so after did all this rewiring and then this mechanical stuff, Orange was down to basically completely disassembled down to like the bottom plate here. And this is what it will, kind of what it looks like. Still being reassembled.
That didn't make it too front heavy? Do you have to like?
Right, so
support under?
well, at the same time, I was adding, you know, a double battery here. So the battery is like another battery in the back. And Orange is kind of already back weighted a little bit because the back goes further back than the front. Like and yeah, and also it goes up. Yeah, this is what it looks like without that. So because this arm, I still have to do some tests. You know, how far out can I use the arm and what load can I have on it? But it wasn't stopping me from doing. You know, I'm not going to stop the presses from doing this design. It's just like it's going to work. It's going to work, or I'll make it work by adding weights if necessary. So like lead weight could be added to the back, but so I mean, so far this arm is not that heavy. And the batteries, adding a whole new battery pack added weight on the other side of the axle. So that's helping. But so far, like what you saw here, like this is mounted, or this one, yeah, I think this is screwed in. It's not tilting. It like the robot tilted down a tiny bit, and that was without the upper levels on. And so here, I added this is a variable buck converter, and which I happen to have bought for a while ago, thinking, maybe I'll use this at some point. Well, now it's definitely needed because those servos are 6.6 volts, and so this will nicely dialed in 6.6 volts, and now I can, so for the serial bus, motors here, servos, I now have a power supply for them through that buck converter. Yeah, so this is what the final assembly looks like now with everything put back together. No tray. I'm leaving out the tray, which is it's an accessory. The tray can pop off if you want, and so is this arm really. So that like the robot is configurable, I'll say. And yeah, this is the battery pack. So I have two of these. I don't know if Jim is still here, I guess he's out. So, but so these are very convenient. You just plug them into the wall, or in fact, one of them is hooked up to this external battery terminals that goes into my charging station. And then this is I already showed this in prior meetings, but this is the AI brain of the operation, the Jetson Orin Nano, which was also on its own little 12-volt battery. Now it's on the main system. So that's nice. That cleared up enough space for that regulator or the buck converter. It's like space is a premium on this thing, and it's like barely fitting everything in. And this is another regulator. Now I have 3 regulators. for the different operations.
That's a pretty beefy buck jump. What's the?
This one's a buck boost.
Buck boost?
For a golf cart, and I'm not sure why I bought. Well, it just came in a large case, but it's really just a. And I sent back the 10 amp one. This is just a 6 amp, 12 volt. It's not that big, but it's bigger than the. Yeah, you can see it's not that much bigger than this thing. But I think that the biggest part of it is the heat gate enclosure to make it waterproof, and I'm not gonna, it's only a 6 amp, 12 volt thing, so it's maybe bigger than it needs to be, but it fit nicely into my design. That was there for a long time ago. Yeah, you can see it another angle here. That one's been in part of Orange for a long time, and that really helped keep the Latte Panda a little bit more stable, because the Latte Panda has a built-in regulator from like 11 to 12 to 14 volts or something, but my battery discharges down to 9 at like 10-15%. I want to use my battery more than 50% of it. It's like, no, I'm not satisfied. So the buck boost helped that, because it'll go all the way down to the 9 volt of, basically take the battery down to 10%. The design is to be able to discharge down to 10% of battery SOC. And that's reasonable. I don't care if that reduces the lifespan. That's what I want, And, okay, so then the last, so what I'm doing now, this is the original, Jetson Nano old one, 4 gigabyte, and the Yaboom breakout board that connects to and so I can go through the old lessons and on this ROS 1 system, and go through the Jupyter notebooks and take a lot of information down about the motor ranges and the calibration information, anything I can get, so that I can re-implement that on. This is going to be driven by the Jetson Orin Nano now, also running Linux, and eventually we'll either move it to start with, and then eventually move into a neural, like neural sort of driving system. But I'd like to learn Move It, because that is just that I didn't learn that, and Move It is a standard non-AI inverse kinematic system that has been used for ages to drive arms. So I think it's worth my time to. But we'll see what happens. And then here's a close up of the. This is the original sort of working. I need to put it on a mount, because this one's bolted in, so I need to make another mount so it doesn't fall over. And then here's the latest design, I guess, of the 2 motors, and the system, and I'm sorry, the 2 batteries, how it's distributed. But yeah, I don't have to go through that now. But anyway, Claude was helpful, and to balance everything out and warn me about stuff, and so yeah. So any questions? So hopefully I'll have a working arm on the robot to pick for a contest, to pick up a can and move them.
I think you showed this already. Have you ever had that arm moving and doing things?
Yeah. Well, that arm I brought to a maker fair and had it using the Yaboom software, picking up blocks, using its little camera and detecting color. And then it was just for fixed positional movements, really, so far. Nothing like it did some detection, like if you could hold up the block and it'd see, oh, that's red, and then you put it down, and into the red area, the area that was designated for red, and then it would go, okay, I know it's red, it must be in the red spot. So it did things like that, but nothing, and it worked pretty well. It could stack the blocks up and unstack them just from fixed location memory. And that's the demo. So it ran in demo mode. Now I'm like, this is a perfectly good enough hardware to do AI powered or at least inverse kinematic powered arm movement. So with much better software, or well, still ROS 2 instead of ROS 1, and then grouped or eventually neural training and policy and being able to like spot an object and find it and pick it up unstructured. So that's the longer term goal.
If you haven't looked into it, do you know about Lay Robot?
Yeah, and Little Robot is, I've seen people with their Little Robot reference design with the arm on that little robot, and their software sounds really good.
Yeah, because your robot platform right now is an upscale with TV. It's a mobile or platform.
Yeah. So it matches the little
You
robot.
might be able to pull a lot from.
So maybe so thanks for reminding me about that. I kind of hadn't connected that, directly.
Lakimi would be the mobile version.
Yeah. Little Robot is the company, is the organization, right? Or is it the?
Yeah, the robot is the ARM project. And
it's the ARM.
The ARM plus the base project.
Right.
The ARM is called SO101.
So 101. Okay, good.
Yeah.
All right, thank you.
Thank you, Jim. So I started to mentor my local high school first robotics FTC First Tech Challenge team. And I found out that it's a pretty large team, like 20 people. So at the beginning, everyone has a role, mechanical, electrical, software. But once they enter the competition season, they really only need like maybe 3 or 4 people. They need a driver and a little pit crew. So I was thinking that it would be nice to supplement a program like that with something where each student, if they wanted, could own a robot. And I think actually learn more about robotics from a simple robot like this than they do from the things in the first competitions, which are excellent for mechanics especially, but not really that great, especially for things like autonomous operation. So I've started to design this. It's basically, the objective is to be, from an educational point of view, roughly equivalent to a ClearPath TurtleBot 3, which is a $2,500 robot, but at an order of magnitude cheaper. So maybe $300 bill of materials cost. A third of that would be for a SlamTech RP1. So really, really low cost robot. It's based on an ESP32. And in order to keep the cost low, I'm going to actually run micro ROS over Wi-Fi and have all the expensive computing done off robot. So basically, one of the key innovations, I guess, is I'm using these $1 TT motors. So it's a brushed, a brush motor with a 48-to-1 reduction, but I'm operating it in full closed loop feedback by using a $2.50 AS5600 magnetic potentiometer. It's basically an encoder. That's way
Yeah.
higher than spinning wheel IR thing.
Yeah, one tick of the 12 bits is 5/1000ths of an inch ground travel. So it's like way overkill.
That thing measuring is like wheel odometry, or what is that?
It's basically an encoder. It's magnetic. It's a magnetic Hall effect potentiometer. And they're amazing. You guys really AS5600.
How does that hook in?
How do you hook it up? It's I2C. Where you can
physically, physically, how does it mount to the motor?
Okay, yeah, that's a tricky thing. Okay. So it's a magnetic encoder, and the way that it works is the ASIC is like this, and then you have to have a diametrically polarized magnet, so north and south, spins like this. So I have round magnets on there, but they're diametrically polarized. They're not axially polarized. So north and south is, as the thing spins, it goes like this.
Diametric. Oh, so it's
Yeah. And the first set I bought off Amazon, they came with axial magnets, right? So they couldn't work at all.
well, axial is just north-south.
Yeah, like a bar magnet normally would be.
Yeah.
Yeah.
That one is called axial. Or,
Yes,
I mean, it's called
like,
diametric.
circle, right? Like,
Oh.
you got this puck. And then normally axially magnetic means north and south are through the puck.
Through the puck.
But in order for the sensor to work, your north-south poles have to be the other way.
Diametric.
Yeah.
Oh,
Yeah.
diameter.
Yes.
It's diameter.
Yeah. So anyway, the way that it works
Oh.
is that I put a lot of effort into this. I designed a custom
Okay.
PCB,
Took a bit of.
and that integrates this whole thing together. So it establishes the proper spacing between the encoder and the magnet. The magnet is, these are double shaft,
They're double.
double shaft. So the inside shaft, I made a magnet holder that just presses on. And it's all engineered so that when you press it on and assemble it with this PCB and stuff, everything's like perfect.
So
And
when
so
it turns, both, the magnet's turning.
yeah.
Same as
And
the
it's
other end of the axle.
it only gives the angle. So you have to count the turns.
Yeah.
So the motors run at like a max of about 500 RPM. And the scheme that I'm using is I measure the wheel angle at least 3 times per rotation. And then I can determine where it is and which direction it's moved in if it's crossed a zero crossing point. So yeah, these encoders are amazing. You definitely should look into them. You can interface them by I2C or analog, which I tried and did not work well at all, or a digital pulse with link, which I think would work very well. And that'll actually save a pin because you only need 1 pin instead of clock and data for the I2C. So that's really the real innovation is you get a closed loop motor assembly for a bill of materials cost of $6. Yeah. And, equivalent thing, but with a microcontroller built into it from Lego or Vex is like $45 to $60. So the way that these are driven, ESP32, and then I'm using the dual H bridge, the 6612 one that I saw on some part of your robot.
Okay.
And so I'm pulse width modulating these motors. And then I have 2 DC to DC buck converters. One of them is to give 5 volts. That powers pretty much all the electronics. And the other one you can adjust for maximum motor voltage. So if you give this to like a middle schooler or a kid and you don't want them like doing wheelies and flipping and crashing into things, you can govern it down by adjusting that DC to DC converter. You could do it in software too, but the main reason why I did this, interestingly, was I didn't have that at first when I was prototyping. This is still prototype, but the first iteration, I had full 9.6 volt battery voltage going to the motor, and I had bugs in my PID algorithm, and the motor was going full speed forward and reverse, and it melted the gearbox because they're nylon gears. It was going. So I decided, like, for preventing my stupid mistakes, I could turn it down. So yeah, the purpose of this, it looks like a toy, but it's actually going to be a quite capable robot, fully loaded. It'll have OpenCV capable camera. It's probably going to be a Raspberry Pi Zero W with a Raspberry Pi camera. And then it'll have a SlamTech LiDAR 9 or 6 axis IMU. So I hope to be able to get it to drive around in a wheelie. NeoPixels and a mono speaker. So the dream vision is, let's say 8 of these, let's say at the college or high school level, with micro ROS going to a ROS platform and the 8 robots doing a drill team drone display, like say a figure 8 where they never hit at the ROS. And they're playing 8 channels sound from the different robot speakers and doing a light show with the NeoPixels. So the real effort in this is going to be developing the curriculum. Right now I have it programmed in MicroPython. So you could see it. I'm actually using the wheel encoder to change this menu.
Oh, smart.
And
Well, you've got a dial.
I like it.
yeah, I have a dial. I could do it from here.
That's
I'm
for
gonna,
something else.
I'll probably make it both, but I use the wheel for this demo. So I'm going to put it
That's neat.
in mimic mode. So now I'm demonstrating closed loop feedback control with a PID algorithm. So this gives you the target angle. The microcontroller reads them both and uses PID to correct.
Oh.
And what's great about this is I can give a practical demonstration of integration to a middle schooler. If you grab this wheel, don't strip the gearbox, but if you torque it off target and hold it, you'll feel the integral build up, the correction over time. So, you know.
Oh, it gets hard.
Yeah. And there's a torque limit on it. Otherwise you would strip the gearbox.
Yeah.
So, my current status is the main board is all soldered breadboard. It's very ugly. And that's the stage I'm at right now is I'm laying that out in KiCad. And I'm actually trying to use Claude code to do the PCB design only through description, like no handwork. So it'll be using something called Skittle to ingest the specs, come out with the net list, and then a MCP thing that actually literally drives the KiCad GUI to do the layout and the routing.
Oh.
Yeah.
It's an MCP plugin.
Yeah. And I've never done this, but other people have already done it, so I know that it works.
I've done just footprints, say, make the footprint file.
Yeah.
And that works fine. So maybe that's your way more advanced, but like, it's amazing that it can make a footprint just based on my description.
Yeah. Yeah.
Oh, you just use like Claude or use the
Yeah, one of those. I don't remember which one. But
footprint and it comes
Right.
out.
Yeah, this is something like for society, I'm very worried about
We're all going to be
the impact of especially agentic AI is going to be far more reaching than what most people are thinking. They're thinking, oh yeah, the software engineers are threatened. The threat to physical processes is going to be great. So yeah, that's the idea. And Ross, hello. Ross is in the Lino Robot 2 online group, and Lino Robot is actually a robot kind of like this. It runs MicroROS, and so I'll be probably leveraging that project quite a bit.
What age group is this age for?
From middle school, which would primarily be engagement, so mostly playing games. So I have a whole bunch of add-ons that I plan to have. One of the more sophisticated ones would be maybe not the Raspberry Pi camera because of latency, but maybe a FPV camera like for drones. Have the kids wear a heads-up a display and then drive the robot with the controller. I can show that to you. And then they would drive the robot from the first-person view from the camera. And then there's a very common game you guys have probably seen, Pinata Bot, where the robots have a balloon and a sticker and they drive around combating, trying to pop each other's balloons. But imagine doing that where you're not looking at the robot, you're seeing the first person view. And then there's a lot of other things you could do with that setup, maze solving, whatever. So this is it in RC mode.
You've got the caster in front, or
Yeah. Oh, and by the way, this robot's name is Ping because it's a ping pong ball. And the first prototype, I couldn't find my ping pong balls, and so I used a champagne cork. And the brand of champagne was Rotary, so that robot's name was Rotary.
So you think the ping pong ball in there?
I designed basically 2 rings.
Oh, okay.
This is almost all laser cut.
Okay.
So the robot will be able to be 3D printed, laser cut. And then I'm going to make this as a product, even though it's open source. And then for middle school, I'll probably come up with a stamped aluminum chassis to make it rugged. But to answer your question, yeah, I use laser cutting a lot. I prefer it over 3D
It's got
printing.
an inner sleeve like that that holds it in place.
No, it's just 2 rings that sandwich the ping pong ball with some slack.
Oh, okay.
That's it. Yeah, so that's pretty much it.
Very good.
Oh, and this is Stanley. He's a magna butt.
Sir, your name?
I'm Dennis. And if any of you guys want to cooperate once I open source it, I'll probably be using Claude to try to do some curriculum development, but there's going to be a ton of add-on work once the basic thing is released.
Looking forward to it. All right, Ellen.
All right, so I got a small grab bag of a couple of things. First off, Jim, I think you were talking about the VL53L 8x8 time of flight imager.
Could be. Yeah.
Both Brian and I have some experience integrating that into a proof of concept.
Oh.
So just here's a quick demonstration where I wired it up to a Radsta 03W and with some stuff on screen to represent distances, just to give you a rough idea of what the data looks like if you're planning on identifying shapes for things you want to grab. So it worked pretty well. It supported 400 kilohertz high-speed mode. I can't remember what that translated into in terms of a data frame rate. I think you're limited by the sampling, but yeah, so it's a fun little thing. I wanted to integrate it to a small robot, and then I got distracted and haven't gotten back to it. But yeah, they're out there. There's code available, and they're a lot of fun.
Okay, good.
What's the range on one of those things? Like how far away can you reasonably see?
Shoot, I think I get mine like 2 meters, maybe 1 to 2 meters.
Okay.
What's the minimum range?
Minimum range is pretty close, like 100 millimeters, something like that. It's not right on.
Yeah,
but pretty
because for
close.
what I want to do, I want it done with the hand so that you can judge the shape of something that's near it. You can appreciate the hand before trying to grab it. So I need a short range. That'd be about 2 inches, right?
Yeah, we have to look at
I
it.
looked at it. There's different versions and different power levels, and depending on the power level, you use lower power levels to go closer.
Nice.
Yeah. And so my second thing is I accidentally bought a lot of extra Raspberry Pi 2040 zeros. So if anyone wants one, I can give away a couple. If you can think of something fun to do with it, I am happy to hand them out.
How many did you buy? Oh, I'm not volunteering to buy.
Okay.
Like,
Well, I bought
something.
10 and I couldn't figure out where they were, so I bought 10 more. And then I ended up using 5 for this project,
Yeah.
but still left me with quite a few extra.
How much were they?
Oh, shoot, I bought them in bulk, so maybe $2 to $3 each, yeah. But, I'm happy to give them out to anyone who wants to play with them. They're fun, they're small, they're a full 2040. No Wi-Fi and Bluetooth, so they're not like that ESP30 keyboard, which is also a great value. But yeah, just hit me up. I got the bag right here.
They're lower power than the ESP32.
Yeah.
That helps a lot for using so many of them.
Yeah. And the last thing is, I just wanted to bounce this off of you guys. So as part of Alfie's Gen 2 ARMS, I'm going to apply a 3-to-1 gear reduction to the serial bus servos to make them stronger. And the gears are available. Unfortunately, they're not cheap, but it'll be worth it. And generally speaking, I know where they're going to fit and how I'm going to support them and where the apps are going to be in. Like that part's very straightforward for me. But I have a challenge. The serial bus servos in their firmware allow you to tell them if there's a gear reduction in play, an external gear reduction. So I can tell the servo that externally there's a 3-to-1 gear reduction. And once you do that, it starts counting off of its 12-bit magnetic encoder up to 3 rounds before it resets.
By the way, I'm pretty sure they use the AS5600.
Yeah.
Is the encoder in those servers?
Yeah, and that's in your BLDC low gear motors. The cheaper ones will have one on the input shaft with some math. I think most of them now have one on the input and also one on the output. And Like, it's crazy that fine is paired up with what could be the world's cheapest gear motor. So I love that. Right, then it makes sense to do it. Yeah. So, and it sounds like I may have answered my own question, but so this is what I want to do for about 2/3 of the joints in both of the arms. But that means that I have to somehow keep track of which in the 3 rotations the robot is during power up. So once it's powered up and we figure out where it is in the 1/3 rotation, you can do all the math and everything works. And I don't know if I need to have a potentiometer on the output shaft and then fed that into the microcontroller. I was thinking that because you know the max and min limits, or you apply a min and max limit during power up, you could assume that when you hit that limit that you're at a certain position in the 1/3. You could have a limit switch halfway through the full. So if you know the actual 1/3 position and if the switch is triggered or not, that, like, if you've ever torn apart an Omnibot 2000 arm, I've done that. Like, that's something that they do. I just wanted to see if anyone had any opinion on how to do this, because I love this idea. This is actually the cornerstone of the next generation stronger arms. But I haven't figured out how to determine which in the 1/3 of rotation I'm in, based on what random position the arms are in. Or maybe I just assume during power up we're at that position, and then we can run a quick max test to verify based on offset. That's the one thing I haven't 100% solved in my head as I move forward with designing these new super servos.
Yeah, you've mentioned all the techniques that I've seen and used. So a lot of times you'll drive the robot arm to a predefined pose. A lot of time for an arm like that, it's straight up. Yeah, and then you say, okay, that's my reference position, and then it goes from there. Like my CNC machine, when it homes, it uses a optical interrupter. So there's a little flag on the actual axis, not the motor. And when it goes and hits that flag, it knows it's within 1 revolution, and then it just comes off. I can't remember exactly. It comes off and then, like, assumes this certain position. So
These things work best if you have it move into it and stop, and then back it off real slow to where just the optical beam goes across. Then you know exactly where it is.
So, like, build in limits to each joint, and then.
But it is the
approach
limit.
that
It is the
immediately
limit because
until
the
you-
vein can go through the optical interrupter right through.
Okay, so like a
It's really-
potentiometer.
it's not a hard mechanical stop. It's just optically detecting where it is. Just optically detecting where it is. But I'm saying there's an optical beam across there, and the piece that you're on the arm will go through there, and then when it interrupts it, stop and back up real slow. Then you get an exact position.
I think you could also do a separate encoder on the joint, basically, and just encode the position of the joint itself, rather than worrying about, like, decouple the position of the joint from your servo.
Yeah.
That seems tighter because all these limit switches on these arms, you have to have 2 sets of, if you use
and then-
your method, you just put it right on top of that secondary shaft.
And then I think you shouldn't have to do any, like, power up verification, limit switch checking, blah, blah, blah. If you have an encoder that's on the joint itself, you just know what it is at power up.
yeah, if it remembers, yeah, it has to be have memory. That's the way universal robot cobots work that way.
Okay. Yeah, with your encoder you have right now, it knows where it is on power up, right?
Yeah, but it doesn't know, like, say in the arm, if the motor can go, it doesn't know, like, where the arm went.
No, but this one isn't going to go in more than 1 turn, right? So
Well, yeah,
the
so
secondary one.
the serial bus servo itself has a magnetic encoder, and let's call this the input shaft. So I always
Right.
know where in the 360 it is to within, like, 100.
Sure. So your output shaft, it doesn't go more than
No,
30,
this is
40.
continuous rotation.
Yeah, so the output
Oh.
shaft it's a 3-to-1 gear reduction. So if I have 180 degrees of rotation in here, that means that I could have
Yeah, these are for arms. They don't go 360. They just go however far as arms go.
Well, so this is not gonna spin around?
No, each joint is generally limited to 180 degrees, but that still means that I'm spinning 1.5 times.
No, but your output shaft, the one that's linked to your arm, you throw a second encoder on there and you're gonna know about where it's at.
That's what I'm saying, if you're encoding on the joint itself that's moving on
Yeah.
the elbow or whatever. Then you're not worried about where the servo is, you're worried about where the joint is.
And that way it's really tight. You can package this all together now as one.
If the joint can only rotate 180 degrees, you don't have to worry about doing the full rotation anyway. You should be able to just get an objective position because you know the range is considered.
Yeah, those are the kind of two extremes right now. On one, with no additional hardware or wiring or sensors, some type of a limit and a soft reset to determine resistance. And then on the other end of that is a magnetic encoder or a potentiometer or a simple limit at the 90-degree mark to determine what half of the range you are and then the use of that. Okay.
Yeah, Dennis can sell you some boards, right?
Amazon, man. All the stuff I mentioned too, that's all Amazon pricing.
Oh, I thought you built the boards.
The little board that integrates them, yes, but that would not be suitable because that board's custom for the GT motor. Yeah.
So, okay, all right, those are my rocks in the hard places. So I'll get him built up first. We have the contest, and while the contest, I'll continue designing the arm. While I wait for the same set of software advances that the humanoid robots are waiting for, and we're both using it at the same time, and they get it right.
The groups.
And I plop down my credit card for the first robot to be less than 20K. Anyways, we will see. All right, thanks, guys.
Thank you. And the last on the list is Thomas.
Hey there, guys. I've been working with AI, as a lot of you know it, and I wanted to integrate AI into an Arduino. A lot of people have integrated AI into Raspberry Pis because a Raspberry Pi is a computer. An Arduino is just a microcontroller. It needs a computer if it wants anything more than that. So what I did here, and I talked about this before at some of the other meetings, but for those of you who don't know, this is an this is an Arduino R4. It can be plugged into a battery and it has Bluetooth and Wi-Fi. I'm utilizing the Bluetooth, because Wi-Fi is a pain in the butt, to talk to my laptop. On this laptop, I have several different kinds of AI, several different models of AI. And the first challenge was getting the laptop to talk to the Arduino. And of course, the Arduino moving the servos is fairly straightforward. So leaning on one of our good friends here, his name is Claude. Anybody here from Claude?
Oh, we're best. I throw so much money at Claude.
Yeah. And he helped me build a bridge from here to there. So we have software here to listen, and also reply, and software here to listen and reply. And it talks back and forth over the Bluetooth line. That was a little bit troublesome. Even Claude stumbled for several hours of iterations. I finally said, look, let's start over from the beginning. Let's get one thing working and then build on that. And sometimes that's what you need to do to AI when it gets stuck in a loop and it can't get out of it. Because it's a feedback loop, because it's looking at what it said and then it's trying to say more about what it said, and it's trying to say more about what it said. Correct me if I'm wrong.
I haven't written code in about 6 months. And then for me at least, and I'm okay saying that. I wasn't hired to be a developer. But I've gotten to the point now where I found that I am not the weakest link, but I'm the bottleneck on that. So where I'm at with now the cloud development, it's not just figure out this thing and do it. It is run it, test it, until you get it right. Let me know when you're done.
Well, that was supposed to work, but mine ran into a problem with the Bluetooth. It was crashing into some other module. They shared some data stream, and I had to separate them. And when Claude realized what the problem was, then yes, Claude separated them.
Okay.
But it took a lot of effort. Anyway, once I got past that, I was able to move data from here to there. I'll give you a short example here. This is called my PC to Arduino bridge test. So it's running right now. There's an LED in the middle there. I can turn it on. I just say pin, put it in the right place here. Pin 5, turn it on, which is a 1, and tell me if it goes on. It didn't go on. You don't. Oh, sorry, wrong. I got to remember how I wrote this. Aha. Let's start this again, just fish. Yes, it worked 5 minutes ago. Give me a second. I'm gonna reboot it. Hold on. Just restart everything. There we go. We're gonna power this on and off. Oh, it doesn't have to be plugged into the computer. This is just providing power. There are no signals going through that. If anybody has a battery, you can make me prove it. But I didn't have a battery in. Okay, we try it again. Scanning for the bridge. It's connected to the bridge, and we try it again. Pin 5, set to 1. Unknown command. It was working 5 minutes ago. Oh, that's right. I don't say pin. I say set, not pin. My own fault. Set 5 to 1. Yes. Hey. And now I have it set up for servos and ultrasonic sensors and reading any pin and writing to any pin. So that pretty much covers 99% of what any of us would do with an Arduino. So let's move a servo just for fun. Servo, that would be on pin 3, and we want that arm to go up. So we'll set it to 0. Ooh, it moved. All right. And if we want to put it back down, we can set it to 180. So the path is working, the bridge is working. So now let's add Olama chatbot. And I wanted a chatbot, and I want a small chatbot because it's got to fit on this 7-year-old computer. It's got a few upgrades, but it's still a pretty old computer that's slower than most, and it doesn't have an NVIDIA GPU card. So let's run it. There's still people online. Should I share my screen? Should I join the conversation and share the screen?
Not the rest of us can see it also.
All right. Let me open my email. One of these days, I'll get here at 10 o'clock and listen to Alan's lectures. I do listen on the Zoom call when I get up. You have to let me in the door, or is it already that day?
You can just jump in.
You connecting me yet? Maybe it's time. I'm running Wi-Fi from the phone because I couldn't connect to the.
Quite a bit of Faraday peak, so that may or may not, you may or may not have enough signal to do that.
Oh, well. I've heard of Faraday cages. They're pretty brutal on signals in and out. Maybe it won't get us there.
Do you want the guest Wi-Fi pass?
Is that gonna I tried connecting, it wouldn't even connect to the public Wi-Fi.
To each guest.
Wouldn't.
Do
Refused.
you have today's password?
Nah, I wouldn't even get that, Bart, for the password.
Well, we have it if you want it.
But it says it's connecting the Zoom. Let's see what happens. Not a lot happens on the screen anyway, so. Okay, I got the little waiting image. There we go. It's launched Zoom. And
Recording in progress.
I don't know if this will work.
You have to disconnect your audio.
Yeah.
And you won't hear the robot responding.
Oh, yeah.
He,
I share his account for the AI meetings on Thursdays. Yeah, that's my alter ego, Camp P.
Oh, he has to.
I'm going to shut this down because although I can show you the code, I can't demonstrate it with the connection. Details. All right, those at home will just have to trust me that this is working. Okay, so again, the biggest problem with having a chat bot on your local machine is if you have an older machine, even a newer one, they run really slowly. You'll say something and it might take you 30 to 60 seconds to get a response. Am I right? You get that problem with a standard laptop?
Yeah, if you're running it locally.
Locally, because I want everything locally. Because you go out to these events, a lot of times you're not going to have Wi-Fi, or it's going to be crowded, and you get your bandwidth is like this. I'm sorry, I interrupted you. You were saying?
Oh yeah, if you're waiting for a response and you have thinking enabled, and if you're generating like 5 and 20 tokens a second, yeah, it can take a while.
Okay, so this is the local one. I found a small chat bot that is fairly good. I'm also running voice recognition. This is Whisper, a small version of Whisper. And of course, the text to speech is built in Windows text to speech, so it's pretty good. So here we go. Yeah, I've got to kill the other script first. There we go. Only likes to run one at a time, you know. Oh, great. This is the one without voice recognition. I typed hello. Verify that it's working. And it responded, don't waste my processing power with small talk. What do you want? I gave it a personality. Anyway, just to prove that this worked. So now that I had that working, I'm going to kill that off. Let's go to the end result here. I'll never get used to Control-C will cancel a program from the terminal. You know, it's just, Control-C is copy, not kill. Should it be Control-K?
You have to come from the Linux world. I've been using Control-C since 1980, I think, 81.
I was in the Apple world, and then I moved to the Windows world. And very reluctantly, I moved to the Linux world. And so, yeah, I know all about it.
Control-C goes back to mainframe, actually. It goes back to the 60s,
Wow.
70s.
It's a Unix system.
I know.
Or
that.
even RISC RSTS. I was
If you-
using RS or VAX or, you know,
If you
BMX.
really want to get into an argument, tell somebody that Linux is the same as Unix. Oh, they hate that.
Anyways, Control C kill existed before Windows, before Apple, before all of it.
Okay, so I'm launching this other program, which is supposed to be the whole enchilada. It's got voice chat. It's got YOLO for face recognition because I tried Moon Dream too slow. And it's got the connection from here to there to control the robot. And if it runs, okay, let's see, is it running or it's not? Try that again. Okay, gonna run it, starting now. Okay, it's loading. Hopefully it's not gonna take an hour. Next time I'm gonna record this ahead of time so I can say, look at my video. It's still loading. Anybody have a good robot joke they want to tell while we're waiting? Loading Whisper now is telling me that.
You're saying Whisper is a chatbot?
Whisper is a voice recognition software based on an AI. It has its own models. It has small, medium, and large, extra large. I'm using small. Loading. YOLO. YOLO is you only look once. It's great for faces and people. It's not so good with, cups, glasses, boxes, coffee mugs. Not so good at those. God, this is taking longer than I remember. Still loading.
Well, meanwhile, while we're waiting, is this like a toy that's like $50, give or take, or what?
This was $20 at some shop. I replaced the servo. There was no motors in it, just the feet. It just rolled around.
Oh,
I put a servo here, and a servo here, and a servo in the head,
oh, okay.
and the light in the belly. Maybe next month I'll have this. Give it another few minutes. But I can use this to shameless self-promotion. Can I do that? Do I have permission to tell about my Thursday night meeting?
Right.
Every Thursday night, I have an AI meeting. We discuss AI, everything from robotics AI to art AI to voice recognition to video AI to AI that'll write songs for you. I was working with that last night, all locally. Amazing stuff. Come on, you slowpoke. Thursday nights, 7 o'clock. I'm also part of the Homebrew Robotics Club of Northern California. I have a friend, his name is Camp Peavy. That's not a place, that's his name. He used to live up there, now he lives in Florida, and he runs the club from Florida. And he shanghaied me into, he graciously requested that I become his vice president. So, yeah.
What area do they serve? Are they Silicon Valley or? Oh, okay.
Yeah, they're in Silicon Valley, but they got people all over the world. I don't know if it's going to run. It ran. Do we still have that prize where it ran at home?
It seems to have been lost to the ages. No one seems to know where it is.
COVID killed it.
I think we need to have it again. Okay, this is not running, so I will make a demonstration and put it in a video, and I'll send it to the mailing list. How's that sound?
Right.
Anyway, pretend I did real well. Everybody give me a
Thank you, Thomas. All right, so unless anybody else has any other show and tell, that's a wrap. Thanks everybody for attending, and see you guys